Oh my God, I started a little late. I'm exactly 1 minute late. Okay, well, I'm also trying out a bit of a new mic setup, so this is going to be kind of interesting for people to see. I'll go ahead and transfer out of this. And why am I up at the top? That's wild. Chat. Why am I showing up over there? Hold on, let me make that go away. How does that look? Why is this so tiny? I got a tiny little version of myself right there. I don't know, whatever. But I'm trying out something a little bit new now. As you can see, I'm obviously wearing a set of gamer headphones. So I just have like my headphones I normally wear when I'm playing like on the Xbox. Because I wanted to see if this works out a little bit better with having this actual kind of microphone here to really talk into, rather than using or rather than being reliant specifically on the microphone from the computer. So I'm also going to turn down just my levels here just a little bit because it's a little loud. Um, but yeah, so I think we're going to basically go on from here and kind of see if we got some cool stuff to show you today. So of course we're going to be working on the Thunderbolt, basically redesigning the Thunderbolt from where I had previously kind of left it at, which is where I had made my prototype and I did one like pretty much just one video on it, and that was essentially about it. I didn't really put very much thought into it. I mainly wanted to see if I could do it kind of for my own entertainment. And of course, there's a lot more that goes into that. But that's just like the bare bones of it. That's kind of like what I was going for. But in this design, since I had a lot of people that have been asking about the miniature Thunderbolt, that have been saying like, "Hey, are you gonna ever work on it again? You're gonna kind of like advance the design. What's kind of like the status of the miniature Thunderbolt?" Since I had a lot of those questions, I figured this would be a good time to actually scrap the old prototype design, and get on to redesigning it and basically just going and starting over from scratch. So that's pretty much what we're going to be doing today. I will note that I have actually worked on some of the things already. I've got some parts printed even, which I will show later on in the stream. But I guess I could show you right kind of like right now. Like here's the stator cap for the miniature Thunderbolt. So a lot of the stuff I've already kind of designed and kind of worked with. Um, but yeah, I guess this is going to be kind of a bit more of the complicated stuff. So such as like the rotator mechanism, the blower section, as well as like the horn and all that associated kind of all the associated stuff. Um, so I guess without further ado, we'll get into that. So I got a couple people that are joining the chat right now. CNY Siren Boy returning, of course, says hi Connor. How's it going, man? Siren Guy 911. It's me. I always talk to you on Etsy. I'll prove I'll prove I'm back. What sign are you gonna make? I guess what siren? We worked on the miniature Thunderbolt, so I guess you'll be seeing that pretty soon. For some reason, I don't know why the chat box is not popping up. It should be right here, right? Yeah, chat should be right there. I don't know. Odd. Hmm. Yeah, I don't know why the chat box isn't popping up, but you should be able to see the chat besides this little thing that's over here. And of course, I got everyone driving down my freaking street right now, being as loud as possible. No, let's move chat over here. Why not? I can't wait to see the Thunderbolt done. Yeah, it's taking some time, but I mean you're gonna see that all kind of done together here. So I guess we'll get into it a little bit. Let me shrink this down a little bit. People don't need to see me nearly as much. So chat box, alert box. This will make sure I have all my sources ready to go. Um, Somebody said you should make the Thunderbolt 1003. Yeah, I mean I plan on it eventually. I kind of want to get the like the basics of like the simple stuff kind of done first. So just making like a single tone Thunderbolt or like a 1000T basically gonna be like the main focus for right now. Um, but yeah, in the future, of course. So I guess we'll go ahead and we'll hop on in to actually see kind of what I've got done so far. So Now, when we left off the last stream, we were actually working on the miniature alerter, so I can actually go ahead and pull that up right here. So this is the actual Fusion, this is the actual design file for the miniature alerter, which I remember a lot of people were kind of here for when I was actually designing it. But for those who don't know, this is kind of the whole cutaway of that, of how this whole thing actually works. I mean, everyone should kind of know it's just an alerter, it's not that complex. But there is the slice taken away of that, so you can see kind of like a cutaway of the alerter and how that all works. This is also kind of a good explanation of how the rotator works and how the slip ring, the slip rings kind of work in there. Well, they're all kind of held in this little capsule. But this is how the rotator kind of works with the rotator gear drive down here, and then the actual center kind of like bearing portion. And I guess we're not going to be dealing with this today, so I'm going to go ahead and close this and make this go away. So let's not save this because I didn't change anything. And we will move on to the miniature Thunderbolt. But I guess for the sake of explanation, we will start off with the old Thunderbolt design, which I had made over, at least at this point now, almost about 2 years ago. I made it kind of a while ago, and I didn't really spend any time advancing it. So that is one of the downsides, is that I really didn't put a whole lot into making it kind of work super well. Because again, like I was saying, I designed it primarily for my own enjoyment. That was basically about it. Um, let's see if I can pull up the stream right now just to make sure I can make sure this is gonna go well. It's not. I don't think it's showing up actually. That's dumb. Huh. What? Maybe go to channel. Hold on. Just a second, guys. I'm just trying to make sure I can actually have this pulled up. I'm not seeing it. That's annoying. Well, I wanted to see if I can pull the stream up so I actually can make sure this is all going to be going well. But anyway. Oh, there it is. Okay. All right, cool. So now I actually can see the chat kind of popping up so I can know kind of like what everyone can see here. So I guess it's kind of sucks because of the way YouTube kind of does things, it won't actually show the chat up on the side, which is kind of annoying. Or I guess maybe it's a Streamlabs problem. Display capture, that's not there. Window capture. No, that didn't change anything. Chat box should be visible. It should be right over there in the corner. Yeah, let's see if open source properties. Yeah. That should be there. Huh. It's weird that it doesn't want to... Yes, I do want to remove Prussia. You guys don't need to see that. That's not going to be really particularly helpful. CNY Siren Boy, I ordered a 500. I can't wait to get it. Yeah, I don't know if you might be actually one of the new people that ordered the 500s. I introduced them for just a little bit because I'm actually missing components right now. I'm kind of in the process of ordering more parts to kind of make some more of those. But you might have been one of the first ones I think that was able to get one. But anyway, continuing on. Enough. I get I get distracted very easily. So we'll go off and start off with the original my original Thunderbolt design. This is the one that is very much a very rough kind of shape of the Thunderbolt. You can tell the horn looks really funky. It doesn't make any sense. And the rotator box, like for relative to the size of the actual, like the actual stator and like chopper section, is also like relatively kind of small compared to it. So the whole thing here just looks completely different. But and I also even have this is saved as a I don't know, I can animate that. That's kind of cool. Oh, I can't animate it. I can actually animate the rotor in there, but there's the rotor itself. Let's see if I can actually go ahead and animate. There we go. So that's the rotor in there. I mean, you guys all know how the rotor and stator works. There's nothing super surprising. But yeah, this was basically like my first kind of rough my rough little design of the Thunderbolt. But I didn't like it. I didn't like the way it worked. It definitely didn't do everything that I really wanted to, and it didn't fit the kind of polish I was looking for. Because again, this was one of my most complex sirens at the time, um, which it was complex, so it took a long time. This is also, of course, when I wasn't super. My let's just say my printing skills have gotten a lot better. Yeah, let's just say that my printing skills have gotten far better now, and this just doesn't reflect what I would actually deem kind of a super valuable thing nowadays. So this is the revised. This is somewhat of like the revised components we're kind of getting into today. So of course this is the new chopper cap that I have made. The port in the center is a little bit wider. It's a little bit wider than what you would traditionally find on the real Thunderbolts, and that I have a reason why I've done that. And it's also, despite this being a 4.5 Thunderbolt, because I'm gonna make it 4.5. This chopper cap is very much like the kind of chopper cap you would see, or stator cap, I should say. The stator cap is very much kind of the one you would find for, like, say, a 1000, a single tone, as it also just doesn't have the divider in between to actually split both the different port rows off. So it's a little different than what you would traditionally find. So I guess if you really want to think about it, the way that this is going to be designed is because the reason why I've designed it that way thus far, with the basically as a single tone stator cap, is because my plan is for this basically to be available in three different port configurations. So it'd be available in single tone, like, this is a regular 5 port, and then it would also be available in 4.5 and 5.6. So that's pretty much why I'm going with this stator cap design and not just kind of like shooting myself in the foot by going with specifically the dual tone stators, because there's really no reason for it. And like at the scale, you're not really going to notice that much of a difference. Now, when it does come time to make the 1003 at some point in the future, definitely not soon, but like when I do go to design a 1003, then I will go in and I will actually re-add that divider so the solenoids actually work properly. So, basically so everyone knows. Um, Silent 65 Gaming, I'm here today. Welcome in. Welcome in. So, let's go ahead, and I guess one of the things we're going to be kind of working on also, here's the motor tube that actually holds the motor. Very somewhat similar to the rest of the way that the real one kind of works. You can kind of think of it like if this section was actually like split in half, for example. If you were to kind of envision it, like say that this is the stator cap, if you were to kind of like split this right around right there, it would be somewhat like that of a Model 2, um, just like the real one would have been. So this is kind of like the way that I have solved for making this thing actually kind of work the way I want to. But yeah, so I'll go ahead and actually adjust my camera just a little bit. Silent 65 Gaming. I'm also next month going to West Shore Services to purchase the Thunderbolt with an AR timer. That's cool. That would definitely be cool. Um, so I guess let's go ahead and move on. So what I'm basically the thing that I'm really kind of going to be focusing on today, like I said, is going to be the horn, or the projector to be more accurate. The projector, the blower box, the rotator box, the compressor section itself, like the blower section, as well as my way that I'm going to make this actually wind down long. I do have a method of doing that. I'm not going to be using capacitors because capacitors are way too kind of fickle, especially with varying load kind of conditions. They can kind of be, they can kind of not really work the way yeah, they're just not really going to work the way I want them to. I also do apologize if this video is a bit rambly and my my voice is a little bit like, oh my god, like, manic. I don't know, or scrambly. So this is one thing to consider, but I just want to apologize for that beforehand. So that's pretty much what we're going to be working on with the Thunderbolt. So I guess let's kind of just jump into it. So this is pretty much what we've got so far. I'm going to go ahead and clear off that because we're not necessarily going to really need that whole bottom section. CNY Siren Boy, I might go to West Shore Services for a single phase Thunderbolt in August. That'd be cool. Yeah, the single phase Thunderbolts are kind of getting it seems like almost like they're getting harder and harder to find now because all of them have been bought up by collectors. I mean, technically all Thunderbolts are pretty much single phase. The only thing that can be three phase on them is the blower. And so you can really just get, it really doesn't matter if you're getting a single phase Thunderbolt, you can get a three phase Thunderbolt and then convert the motors in it to single phase. Because really the only thing that is three phase in it is the rotator motor and the blower motor. Thiago de Souza Vasella, or Vasella. Hi Connor, I'm back. Apologize for that. I sound like such a white boy when I say that. All right, so let's go ahead and work on this chopper, or this rotor. I'm not really going to be doing very much in terms of trying to make this have fins in it, like that of the real counterpart, like the one that's based more of the Model 2, because there's really not going to be that much in terms of air movement that I'm really looking for. I really don't intend for this thing to make very much noise unless it has the blower in it. So, basically just like the real Thunderbolt. So like here is my split Model 2 rotor, which I had used pretty much for the other Model 2 I've made, but this is kind of like the rotor design like you'd think of that you'd see in the regular Thunderbolt. But we're not going to go with that because that's way too unnecessary. There's a lot more plastic in there. I don't really need to do that. I pretty much just need this to act essentially as a rotary valve. Have you Siren Guy 911 says, have you ever almost bought a Thunderbolt? No, I have not. I never bought a Thunderbolt. Um, I've never even had the opportunity to get one. I really could if I really wanted to. I mean, there's many ways to get one. I just don't have much of a drive for it because I live in an apartment. I live in an apartment, I don't have a truck, so there's no really way of transporting it, and there's really nowhere I could go to test it. So it's just like there's not much of a reason for me to want to get a super big Siren. So again, as I was saying, we're not really going to be adding any fins into this rotor, because I think that's just not really going to be able to, that's not really going to fit kind of our purposes. We'll add some kind of fins and some kind of reinforcement to make sure that the walls of the rotor don't actually kind of like flail outwards when it's spinning really quick, because we want to make sure that we minimize kind of distortion of the rotor as it's spinning, especially since this will be spinning pretty quick. So I think a majority of what we're going to be kind of adding in here is not necessarily going to be for moving air, but it's pretty much going to be there just essentially for reinforcement. So, and you may also notice that yes, the rotor is actually kind of somewhat segmented, and that there's not that much kind of going off the bottom. And that's what I was saying, that it's kind of copying the same design I had done before, where there's that ring to kind of hold the rotor together on the top, but it really doesn't exist on the bottom. And that's just because it adds an extra layer of thickness to the rotor that I really don't need, because then it would actually come into conflict with the stator cap. So say if I had this, if you look again at the cutaway of the entire thing, go ahead and spin this around really quick. If you go ahead and look at the cutaway again really quick, so you can actually see here, right in here, this is the section where the motor is actually going to be sitting. If I highlight the rotor, you can see that the rotor itself, which is this section in here, obviously, I need to make sure I maintain a tolerance between the bottom of this actual stator cap and, sorry, here's my watch. I need to make sure I maintain a pretty good level of tolerance between the bottom of the top of the motor cover and the interior of the stator cap. So if I added another kind of wall or ring to that, that would kind of max out my thickness that I'm kind of allowed here, which is the reason why I'm really not going to be using it, because I just don't see there being much of a need. So, and of course it's going to be internal, so it's not going to matter. Like it doesn't, you're never going to actually see it. So what's the point, you know? That is, unless I that actually does kind of bring me to one idea. I did have an idea of, instead of making this entire section glued together like I traditionally do with most of my models, that this would be the first model I would introduce where you actually could remove parts of it. You actually could take the stator cap off and then you can actually change the rotor in it to make it kind of like whatever tone you want. Um, that was pretty much my main idea with this. So there was going to be a basically like a snap ring that actually, because if you look at this, this is the two halves of the stator cap and then the motor tube. There actually is going to be basically a snap ring that's going to go around this whole bottom lip that will actually hold the stator cap onto the motor tube. And when you want to remove the rotor to change it, you can just unclip that snap ring and the whole stator cap will come off, allowing you to get access to the actual rotor to change it. So let's say it'd be kind of like this. Whereas like there is the rotor sitting in the stator tube. Here is the stator cap sitting on top. That snap ring would lock around the edges, but if you wanted to, you can come in here and pop that off. Be like, oh, I'm sick of it being a 1000. Let me go ahead and swap that to a 4.5. Take the rotor off, pop your 4.5 rotor back on, put the stator cap back on, and put the snap ring back on. And basically, you've changed the Thunderbolt to a different tone, which I think would be kind of cool. Thunderbolt is going to be my first Siren, well, second because I have Connor's 500. 65 says silent, 65 gaming. Siren guy 911. Well, you bought the SD10. Oh, that's true. Yeah. I haven't made a lot of SD10s recently. It's because they're kind of they take a lot of time to print, to be honest. So again, let's go ahead and get stopped. We'll stop talking here. We'll kind of do a little bit more focusing in on how we're actually going to model this. So it does kind of suck not necessarily having that ring around that edge to kind of help us out a little bit. So this isn't going to be super easy, but I think we can definitely do it. So there was this ring that I was going to add in the center, basically to kind of somewhat parse out these ports at least just a little bit. But I guess another thing we should kind of focus on is I do want to put a hub in here first already, so I can go ahead and make sure this is going to be able to mount to a motor shaft. So let's do something a little simple. I don't need it to be super, super big. Here comes my cat again. You guys have the famous cat that's always in my videos. She's coming back over here again to see what I'm doing. She loves coming up to my lap whenever I'm working on stuff. So let's go ahead and make this, I don't know, something like 6 millimeters. I think 6 millimeters is fine. What are you doing, lady? Lady. Yeah, there's my cat. Big fat girl. Go over there. Alright, so, yeah, I think 6 millimeters is pretty much going to be just fine for us. We're going to go ahead and just do that right now. I'm going to come in here, and we're going to add... We're going to add some height to this now. So I want to make sure this is actually going to kind of come up all the way to the edge of this. So let's see if we go all the way up. This should be about the same kind of height. I'm going to have it come out just a little bit to make sure it's actually going to contact the kind of tippity top of the motor. Essentially to make sure that this rotor stays off the bottom section of the motor. That looks pretty good. Looks pretty good. Yeah, let's say right there. I'm gonna say that's probably gonna be fine. So we'll go ahead and join those two together. Get rid of this, go back to the rotor. So get rid of this analysis as well, because we don't need this. But yeah, pretty much just a simple little hub that we're gonna do first. And now we'll go ahead and start actually putting in the vanes. So the vanes are actually gonna run from each kind of port. So this is, of course, like I said before, this is going to be a 4.5 Thunderbolt, because I personally like the sound of 4.5s more than I like of pretty much any of the other Thunderbolts. That's just a preference thing. I mean, it's not the same for everyone. But I really like the sound of the 4.5s. So, because it has like that older kind of raspy kind of sound to it, especially a 4.5 port Thunderbolt mixed with like a 6M blower. Like a big 6M, it'd be crazy to listen to. It's super, super cool. It would have that true growl to it, which is really kind of what I want from this model. So I want to check really quick to make sure that this is gonna have good port duration. I want to check, make sure this is going to have good port duration when it's actually rotating. Basically to figure out essentially having, it's like figuring out the duty cycle of the ports. Okay, it's a little short. It seems a little short for the 5 port. But we'll have to see how it runs. I know for a fact that the Chrysler likes having a very long open cycle when it's running for the ports. It because it has to get that air out of it, and then it's that abrupt stopping of it, and then that big puff again. That's what really kind of makes the growling. That's what I found that these pressurized sirens really enjoy. So I'm gonna say that's probably gonna be fine. I'm gonna say that that ratio or that kind of that duty cycle of each port looks pretty good. I think it's gonna work pretty well. So now where are we gonna how are we gonna I need to find a body I can actually kind of come off of to model the port. So this is the 4 port section on the top. Thankfully I do have when I cut these ports, the holes for the actual rotor, I did undercut them a little bit so that I could actually have these kind of lines there to show me where the edges of the ports are, so that I can actually have a better way of actually lining up where I'm putting each vane. So I guess we'll go in here. We'll do a sketch. I'm going to do sketch with lines for this specifically, because these aren't really going to be these veins are not going to be really thick. It's kind of like not the point of them. They're pretty much. I'm not sure I'm going in the right direction. Where's the stator cap? Yeah, I'm going in the right direction. Okay. They're not really supposed to be very thick. They're pretty much just going to be here to just basically act as ribs to reinforce the stator. So they're really not going to be done intentionally to kind of move air. So I want people to kind of keep that in mind when it comes to me designing these. So I could really do like that if I wanted to have it rotate that direction, but I don't want to make this really necessarily a directional rotor. I do want to keep it somewhat at least unidirectional, like the real stators were, or the real rotors were. So we're coming off of this center line. The center line is aligned perfectly with the hub of this motor shaft. The hub of this rotor, I should say. Let's do about like 150. That means we're gonna have each port, each each vane is gonna be about 3 millimeters, which is perfect. There's 150. There it is. 1.5, 150. I don't know what I was saying that for. Okay. Okay, so you should make a custom port. Siren Guy 911 says you should make a custom port for 6 port. That'd be a very interesting one. I mean, I definitely could. It'd also be kind of fun, like again, with going with that removable rotor idea that I had talked about of people being able to actually kind of like, if I wanted to, I can make a custom rotor for it and then make it available. And people could have like some really like stupid port ratio, like in a Thunderbolt, like maybe like 16:3 or something like really like ridiculous that just doesn't make any sense, because it'd be really interesting to see what it sounds like. Although a 16 port Thunderbolt, theoretically, like a 16 port rotor, that would be insanely high pitched with the Thunderbolt, but it wouldn't be very efficient because a 16 port wouldn't allow it to have a very long duty cycle. So let's see how long this port looks. I mean, this vane looks really thick, even for being a 5 port. Let's pull this up. We'll see kind of what it looks like first before I really call it. I just want to see how this is gonna look. Yeah, I just want to see how this is gonna look first. Let's say it's right there. I'm not gonna purposely move it all the way to the top. So let's just put it right there for right now. In fact, let's make it its own. Let's make it its own body, so you don't have to worry about it. Now I do know that the Thunderbolt did use some pretty thick vanes. After all, it was based off the Model 2, so of course everything kind of in it was really thick. So like, oh, this is a motor I'm looking up for it possibly. So if I come here, where's like the older style? older style. These are all brake rotors. Let's see. Okay, here we go. That's a pretty good design, a pretty good example. Like these are pretty thick vanes, mainly because it's holding up kind of a pretty heavy rotor, but also because they made it thick, so it would coast for a long time. That's definitely at least some part of it from Federal. As of course as the versions or the variants kind of changed, they did thin them out a bit because they had to make sure there's enough space to get air through them. But yeah, that's definitely at least somewhat of it. So let's see what this is going to look like. So it's a very thick vein. It's a very thick vein. Let's see what if I can actually move it around this axis, and we'll do 5 of them. See kind of like what it looks like. I'm not a huge fan of that. Let's see what it looks like. Wow, that looks like garbage. I do not like that at all. I mean, again, like even though I've said before that it's pretty much just going to be there for reinforcement, I don't like that because it means that for air to get through this center section of this rotor, let me move it over a little bit. For air to get in this center section of this rotor and then having to fit in between each of these cross sections to then flow out the port, it's just not a very good design. So let's not go with that port design because it's way too thick. So we'll have to make it thinner. I don't want to make it 1 millimeter thick because I feel like that's nowhere near enough. Let's make it 2 millimeters. Let's make it 2 millimeters thick. Let's see if that makes enough of a difference for me to be kind of comfortable with it. Oh crap! I forgot to get rid of those lines too. Hold on, just a second, guys. Go away. There we go. All right, let me try that again. So let's go ahead and make this 1. I also just bumped the mic. Sorry about that. We'll go ahead and do 2 millimeters cross instead and see if we like that more. I think we might. I think we might like that a bit, just a bit more. Come up. There we go. In some sections, I may also just be quiet because I'm going to be like just focusing on what I'm doing. So if I'm not talking for at least a little bit, just know that I'm not doing dead air intentionally. All right, let's try that and see how that works. That immediately looks better. So let's go ahead and bring back that little kind of ring section. Bring back our analysis so we can see where we are. And we'll go back in here and pull this up. Okay. No, I don't want you to join. No, no joining, please. New body. Because if I do like the way this looks, I can commit to it, where I will go in there and actually physically add it as a new section. But I want to see kind of what it looks like first. What? What? Oh, that did not do what I thought it was going to. Hold on. It extruded the wrong section. I want you to extrude this, please. There we go. That was dumb. Alright, let's try that again. Okay, yeah, that makes more sense. Now it's actually kind of fighting me a little bit. So let's try that. I don't want to join this again, of course. I'm going to go ahead and just make sure this is a new body so I can actually still kind of independently move it. And we'll see kind of what this looks like from there. So that's the vein. Go in here. We will do create pattern, one of my favorite tools. I swear, like I said, every time I use it, it feels like cheating. So we're going here, go to features, and let's do bodies because I can just select the whole thing. We'll rotate around this axis. We'll do 5 of them. Okay, that looks far better already. So that immediately looks better. So I think we'll probably be fine. Although it isn't centered, it's not super centered with that port. So one moment. We'll go ahead and make this. You know, we're gonna add them. We're gonna add them like that, and then I should be able to actually just rotate all of these at once, just to kind of somewhat align it a bit better. So let's move this, move this, move this, move this, move this around this axis. There we go, fixed. Boom. Just like that. That was easy. I swear to God, Fusion is so nice because you can do this stuff so easily. Alright. You should make a custom 456, I mean 4.6 port. Yeah, I was just talking about that. For a 25 1 port, possibly 25 1. It's funny because I tried actually making a 1 port Siren. I actually have it. It's on the floor now. I'll probably explain that in some other video. But actually, no. You know what? Hold on, really quickly before I go away, before we kind of focus more on this. Let me show you where that 1 port Siren is. Where is it? Where is it? It is way down here, is it? This is, I mean, you guys are so bad because you guys get me distracted so easily. I don't end up actually doing much of anything because I end up getting distracted. Here it is. So this is read only. We'll make it editable. I think yeah, I got enough components. Let's go ahead and make this editable really quick. Let me show you this. This was actually a 1 port Siren design that I was working on. Let me go ahead and assemble this really quick. New component, make this a component. From bodies. There we go. Make that one. And then we will make this. I hate that it deselects from bodies. There we go. So now, make them both here. Joint. Okay, component 2. There we go. What did this thing just do? Did it just flip the whole thing over? What a moron. There we go. I don't know why it always has a tendency to move it really close, too. It's super annoying. I really want to show this off, though, because it was something that I thought was really cool that I just haven't talked about. So, I'm just going to give it a really quick little show off. Let's go ahead and animate this joint really quick. So this was actually a 1 port Siren that I had designed. So if you actually follow where the port is, it's technically just 1, but it actually takes an entire revolution to completely open and close, which is crazy. Like it's not doing it. It's opening and closing almost the complete 360 degrees. So in this case, you can see that it's opening right here along the right side, and once it starts hitting right here, it starts to going through its closing cycle. I didn't really do anything with this, but it was just kind of something fun I was kind of messing with. But yeah, all of that just to show you that. This is a cool little animation. I'm so sorry, I keep getting distracted. Alright, so let's go back into this. So, read some chat really quick. 25 1 port, possibly, that would work well. Mississippi Tornado and Sirens and more, 100 port Siren. Silent 65 Gaming Thunderbolt on crack. Yeah, it would be crazy if it was that high of a port ratio. Not even that, not port ratio, just like that high of ports. Silent 65 says, if so, I was just going to say that I can't wait for late spring, early summer for storm season. Neither can I. I love when it's really rainy and like scary weather outside. I love that. It's always so much fun. Siren Guy 911, I'm going for the right port ratio because the Thunderbolt and Model 2 can go up to a certain point port ratio. Yeah, basically, yeah, kind of. Silent 65 Gaming, yeah, the Thunderbolt and Model 2 Siren basically have the same rotor. They really do. They have pretty much essentially the same thing, except for some certain models of them did use different rotors and motors. Siren, the guy nice. One says, yep. Silent 65 Gaming, if I were to get a 5-port Thunderbolt and have a 4.5 Model 2, I could swap them out, I believe. Yes, you can. One day you can make a T128. Yeah, eventually I'll make a T128. I know a lot of people have been asking me to make a T128, and I just don't have a reason to. Like I think I would want to make a either I would want to make a Thunderbolt that works really well first, or I would want to make like a 2001. I would love to make it like a 2001 DC because that'd be a lot of fun. I would probably work on one of those before I would make like a before I'd make a Tempest. Hold on, I'm gonna take my watch off just for a quick second because it was starting to kind of like, oh my god, look at my wrist. Look at my wrist. It was just like it was like just constricting my hand, my arm. So all right. So I think this looks a lot better. I think I'm actually pretty much okay with that rotor thickness. I mean, with that port thickness, vein thickness. I'm all over the place today. Um, why does that not look like it's concentric anymore? Why does that not look concentric at all anymore? What? Is this thing just like messing with my head that just doesn't look right? No, it definitely doesn't look right. That's weird. What happened? Back up. Let me back up. What happened here? What? What happened? It's not even concentric in this aspect either. Did this whole ring like shift over or something? It did. Why did that happen? I didn't move this rotor. I don't know. Either way, it doesn't need to be here, so I'm just gonna go ahead and just get rid of it. So I'm just gonna do that really quick. All right, so let's go back to where we were before we were rudely interrupted. So even 2 millimeters seems pretty thick, but I don't really want to make it any thinner than that. I like this port thickness. Let me see this vein thickness. Let's measure this really quick and see just how thick this is. I think it's 2 millimeters. It looks like 2. It is 2 millimeters. Maybe okay. Maybe 2 is actually not that bad. Yeah, maybe 2 is actually not that bad. Let's go ahead and go with 2 millimeters. I think I'm actually gonna be fine. It just doesn't look right to me. But let's just go with 2 millimeters. I think it'll be all right. Okay, go back to this. We're gonna go ahead and why am I from the bottom? There we go. I'm gonna pull up this first vein about to right there. That'll work. And we actually can go ahead and actually join this now. So we'll go ahead and we will do that. So we'll join that together. And okay, yeah, this is gonna look good. This is gonna look pretty good actually. And then now from there, we can go in, go to create, go to our pattern again. We're actually going to make the pattern now. We're not not just going to keep like looking at it. So features, you can select features to select like things that are kind of already joined to each other in order to move things around, which is really convenient. In fact, actually, let me do this really quick because I can. Because I can. Let's fillet this edge. Yeah, screw it. Why not? Why not? Why not? Who cares? It'll work. It'll work. It just looks kind of goofy now. Can I fillet this too? Oh, I can. Oh, I can. That looks good. Although 2.5 millimeters, it's a little big. Let's just do 2. Okay, that's much better. All right. Improving the air path is what we're doing. Improving the air path. Okay, so now let's try that again. Okay, not bodies. We're going to move features. Why didn't you get all of them? Did it grab all the features or did it grab just those 2? I'll make sure it got all the way around. It did. Cool. All right, axis. We want 5 of those because this is a 5/6. Oh, I forgot to rotate it first. I forgot to rotate it. How many can I actually add? How many will it just do? Oh my lord. Fusion is so wacky sometimes. I swear it is. let me undo all that. That's so annoying that I have to keep doing this. It's because I keep forgetting to do certain things because I'm like so scatterbrained today for some reason. So we're gonna make sure this is doing this as a new body, so therefore we actually can scoot the whole thing over. So go in here. Does that line up right? It looks like it does. 7 mils. Yeah, about 7 mils. We're not gonna join this. We're gonna make this its own body. Okay, and get rid of this analysis so I can see exactly where this rotor vein is. Moved around this axis. Just I'm basically going to try to align it right now so I don't have to deal with it not being aligned later. That is not aligned up at all. Maybe it is. Maybe my little undercutting trick I had done actually kind of screwed me over a bit. Okay, that looks lined up. So good. Now we can save that. Now let's go ahead and do that again because I'm a moron. Okay. Fillet that. And fillet that and fillet that whole entire round section at the bottom. So now, I thought so. I thought you were going to have a hard time figuring that out. So let's do, I guess it wants us to pretty much just do it one at a time because it couldn't figure that part out. So we're going to do one side at a time. Why is it trying to press in? Oh, I know why. I know why. It's because it's not part of this. So we're gonna have to go in here and combine this to the rotor. Just combine that really quick. So now these are both the same piece. Now it'll let me do that. Now it'll let me do that, right? Yes, there we go. Perfect. So simple little mistake. It's kind of one of those things you have to kind of pay attention to. All right, now if I go out, perfect. If I select that edge too. Huh, can you fillet that edge? No, I don't want you to jump to that. I want you to fillet this edge, and this edge. Okay, do all of those edges. All right. There we go. That's what I wanted you to do. So we're gonna do it just 1 millimeter. I don't need to have it be like super crazy all over the place. So do 1 millimeter setback like that. We'll go ahead and join that. Then go back create. No, not pattern on path. My hand slipped. My hand slipped, man. Okay, bodies. Let's not do bodies. Let's do features because it makes it easier. All right, around this axis. Do it 5 times. Oh my God. It's like I couldn't figure it out. Oh my God. Let's just do faces instead. I gotta manually enter them all in, but it's better than having the headache of this stupid thing not being able to figure out how to do that. No, I don't want you to do the whole. What did you select? Did you select the whole bottom? I don't know how you did that. That was my cat squeaking because she's stretched. She's all spread out on my wife's pillow right now. All right, now let's try this again. So it's selected just faces this time. Oh, come on, that looks so cool, dude. Just do it. There we go. My gosh, that was annoying. Okay. Sorry, I had to stretch my fingers a little bit. Okay. CMY Siren Boy, one day can you make a T128? Yes, I can. I believe I talked about that already. Silent 65 Gaming. I have some MSNY. I think you meant to say many. I think you meant to say many. I have some many storm time lapse. I have one of a tornado 5 minutes from me. That's crazy. Well, just the storm couldn't see the tornado. Silent 65 Gaming. Only a freshman in high school, but I want to major in atmospheric science. If that doesn't go as planned, I will work for ASC or federal. That'd be cool. Silent 65 Gaming. I want to go to University of Oklahoma. Any particular reason why you want to go to UOO? UOO? U of O? what's your reasoning? I'm kind of curious now. I mean, you don't have to tell me. I don't know you. Okay, so now we got that. So let's go ahead and actually add this ring that's gonna go kind of continue on this stator a little bit. Or I can actually I can probably even completely negate using the ring, much in the same way that I did with this Thunderbolt. Motor tube. Where's the projector? Make the projector go away. Stator cap, stator cap, stator cap. Where's the stator cap? Stator cap. I can't find it. Whatever. I probably could do it like that. Yeah, I could definitely do that. Oh, that's why I couldn't find the stator caps on the bottom. Because these veins are just floating. And they are just floating. I also just really didn't add a whole bunch of, in terms of the veins anyway when I first made this. This one, of course, is 5.6. This is a 5.6 Thunderbolt. But this was, well, the old one was 5.6. I don't know how I'm going to do that. I really don't want to, I don't trust having those veins just floating because this is going to be, this one is going to be resin printed, this rotor. Whereas this rotor that's in this design right here that you're seeing, this was actually done on the FDM printer, my oldest printer. So I don't really necessarily trust it to do that well if it was resin printed, so I'm going to kind of try to avoid doing that actually. And instead we're gonna add another little ring here. So 36 is not 36 millimeters. I just want you to go to this edge and then stop. It's so annoying sometimes. What size is it trying to make this? Oh, thanks for telling me nothing. It goes away. 36, 37, 36, 37. I bet you it's 36 and a half, something like that. Yeah, I bet you it's 36 and a half. So let's do 36.5. Oh, it's not. 36.8. 9. It's 37. What a weird measurement. There we go. Alright, so now, got that. How much air are we going to let into this thing? So, I really don't want this thing to hold up a whole bunch of space. Let's do like 30. Let's do 30. Alright, I'll bring up that little ring. No, you don't want to go up to 1 millimeter? Oh, that's stupid. Why'd you just do that for? Oh, even that is too tall. That's dumb. That's just dumb. Alright, so it's almost a millimeter thick. That should be fine though. Join that together, and that should make the kind of the whole section be its own thing. Okay. For meteorology, Silent 65 Gaming, for meteorology, just to get the full experience. Heard you go out storm chasing with some meteorologists. I don't know if that's true though. Maybe. I don't know. Sirens of New York. Message redacted. Silent 65 Gaming. Sorry about my grammar currently. Lamau. Oh, that's alright, man. That doesn't matter. Sirens of New York. I'm trying to figure out how to make a T128 rotator for almost a year now. I'll keep trying. Siren Guys 911. I sent you something a while back on Etsy. It's a 2T22 part of the Los Angeles system. Show everyone on the stream. I don't think I'm not gonna be able to pull up Etsy on this right now, but maybe I'll look at it in just a second. It's a 2T22 part of the Los Angeles system. Wait, what? Hold on a sec. Now I gotta look this up on my phone really quick. When did you send me that? Let me check really quick. Hold on. So there's a 2T22 that was part of the Los Angeles system. Um, I don't think you sent me anything that was related to that. I mean, I see all the all the regular sirens. Huh. I don't know. It's not. I don't see where. I can't see where if you ever sent me that. But huh. I see the messages from CNY Siren Boy though. Central New York Siren Boy. I saw him pop up on my Etsy. Uh, but yeah, like you were saying, one day, yeah, I will make a one. I'll make a T128 at some point. So let's go ahead and so we got this one set of vanes. So I think I'm gonna go kind of with the two. I'm gonna go with the 2 millimeters thick um, rotor vanes. I think that works pretty well. I think it will work pretty well. I actually really should say. It also adds a lot of weight to the rotors because it makes them really pretty thick, especially when they're going to be MSLA printed. I need them to kind of be heavy and durable. So, okay. So now's the part I really don't want to do. That's trying to get vanes up here. So I want to see if I can find some reference images of kind of how the rotors were done for Thunderbolt. This is the restoration project. This has been on the Siren Roar for a long time. Yeah, 2002. I remember when I first saw this. I remember when I first saw this when I like first kind of started getting into sirens. I remember watching him go through this, and I thought it was crazy. So even this looks like another. No, that actually might be that might be a 4.5. It's kind of hard to tell. It's really hard to tell actually. This might be a 4.5. Again, I can't really tell because it's just not able to zoom in very well. But this bottom port, the bottom stator row of ports really looks suspiciously like a 4.5 because this is lined up like 90 degrees with this vane. Yeah, it might be a 4.5, maybe. I can't tell. If that's the case, then I was totally right about the Thunderbolt really wanting a long duty cycle per port. I'm not sure why. It might be just because I mean I know why, but it's too long to go into as to why that's done that way. Yeah, so here's the segmented stator port, stator cap. Okay. I also have hiccups. I realize I made the stream mistake of drinking a Coke, which means I'm like a burpy, so I'm trying to like not sound like a freaking pig. So let's no no why not why not we'll just keep going. Uh, it actually might not struggle all that well if I try to do this. So bottom. Nope. Someone sent me a message. I feel like the horn of the T128 will be hard to make, at least for me. I don't know about you though. Tried making one, but it didn't go as planned. We'll try again. I didn't make a T128 in a bit though. Well, all right. Looks like Silent 65's got to take off. Gotta go. I don't know if you will be on at like 3:50. Um, I'll see you then. Bye. Yeah, I guess I'll see you. See if you're on here when I return. When you return. Ugh. Okay. This is probably not nearly as like popping off as a stream of like what I normally would do, I guess. but that doesn't matter. I don't really care about getting a whole bunch of views. Let's go ahead and I just want to make sure everyone's at least being entertained and everyone's kind of, enjoying their time. So, bottom, let's do this. I need to rotate this at least a little bit just so I can at least align this port basically so I can start actually adding the walls of the vein here. So I'm going to rotate the whole entire thing over at least a couple degrees. And now I should be able to actually kind of add this vein here. So we're going to go again with the 2 millimeters. So 2 millimeter thickness here. So come over here, measure over 1 millimeter, measure over another 1 millimeter, and then bring this all the way to the wall. Go over here, bring this all the way to this wall as well. We'll go ahead and come all the way up and we'll just bring this out into the hub. I don't know why it's having such a hard time trying to find this little hub section though. Whatever. Okay. And now we should be able to join this together. Okay, so there we have another vein. No, we don't want it to cut. We want it to join. Let's join this. Let's just do that. Let's just join it. Now, I will say I will be really, really impressed if 3D printer is actually able, the resin printer is actually able to print this. Because in my mind, this looks like it'd be kind of a pain in the neck trying to print this. Um, I don't know. We're gonna have to see. Monica Coon, what is your favorite video game? Oh, yeah, yeah, 'cause I got the gamer set up right now. My favorite video game kind of all time is probably going to be Halo, one of the Halo series. I've always liked Halo. Well, pretty much any game from the Halo series. Halo, Legend of Zelda: Twilight Princess. Um, and as of recently, like my more recent favorite video game series of pretty much like of modern times has been a Metro, the Metro series. So like Metro 2020, Metro 2033, Metro Exodus. Basically, the whole entire Metro series has always been fantastic. Siren Guy 911. I sent you like a month ago, maybe. That's probably why I couldn't find it. Um, what's unique about it? What makes you say specifically that's part of the Los Angeles system? Is it on like one of the older style Los Angeles poles, or is it like one that's like done like privately? Like I know that because I know there's a 3T22 in LA that's like up on like a power like up on like a fire station or something. But yeah, I hope that answers your question, Monica. So I probably actually, you know what? I probably could actually just do this. I probably can add. I probably can add that second ring to this and just deal with it. Because I would feel a bit more confident knowing that the siren is actually held together relatively well. I don't know. That means I would have to either make there be less space in between the top of the rotor and the top of the stator cap, or I would have to just extend the kind of like thickness of the bottom of the stator and actually get it to kind of stand up a little bit further away from the motor so I make sure I have enough space. I don't really know. This is just going to be kind of one of those things that's going to be not super easy to make a decision on. Hmm. Not super excited about how this is. I might mean I'm going to not have the whole thing glued together so I can at least still kind of experiment. Let's get rid of the stator cap. So alternatively, what I was kind of initially thinking was that because I didn't want this thing to necessarily be biased any particular way of like say having like one row of ports be somewhat more dominant over the other. I could even try to get this thing basically just be veinless, where there's no veins in it at all, a lot like the 120, where there isn't any veins and it's just dependent on whatever air can kind of get to it. So say if I did like a port or like a vein kind of idea that looked more like just like this, where it's really not truly much of a vein at all, and it's more of a focus on the ports themselves. I could do something like that. Yeah, that is most definitely an option. Um, However, it's not one I really want to go through. Hold on, one sec. I got like crap in my nose. Sorry about that. I had like some junk on my nose. It's really irritating me. Oh, I just got an Etsy notification. Oh, okay, yeah, I know that I do know about that one then. Yeah, I've seen that one that Douglas did a video on. But yeah, I have seen that one. The 2T22. I saw that a while ago when he first posted that video. Um, it is cool to see a 2T22 in the Los Angeles system. I don't think it was actually used for. It wasn't. I don't think it was actually used for the part of the CD system. It was just there pretty much as like a fire siren. But it's still cool regardless, though. It is still cool regardless. So I think this. I think we're gonna leave it here. We're gonna stick with this rotor design. We're gonna see if this works. I'll print it out. I'll go ahead and slice it and see kind of what we're gonna get out of it. I don't have too much confidence. I will be quite honest with that because I don't think the printer's gonna have a really easy time trying to print that. Um, but yeah, we'll see. We'll have to see. I don't think it's gonna work very well, but that is what these tests are for. So it actually sounds like one of my prints actually just finished. So yeah, we'll see how that works. I'm gonna go ahead and actually just do the hole now for this motor shaft. I forgot what size motor shaft is. I always forget. Let me go to one of my reference sirens really quick. 500 SHTT. Yeah, we'll look at that one again because we always look at this one. This is I use a lot of this stuff to kind of like help me remember my measurements because I don't have it like written down anywhere. So let's see. I forgot how big this motor shaft is. Analysis. No, go away. Okay, how big did I make that shaft? This is for an MSLA print, so this is, okay, 2 millimeters, 2.05. So go back in here, print. I mean, do this 2. No. 2.05. 2.05. Thank you. All right. Go ahead and do that. Go ahead and come in here. We're just going to push this out. Wow! What are you doing? There we go. Made the hole exceptionally long, so didn't need to do that much, but we'll just do it anyway. Who cares? Okay, we'll see how that works. I might try FDM printing this instead and seeing if it works better just FDM printed over MSLA printed. But we'll try MSLA printing. I can. We'll see what it does. I'm not super confident in its ability to actually print well because of those overhangs, because MSLA printers just are just horrible with overhangs. It is kind of big, and I don't have a rotor here to really illustrate how bad it is at overhangs, but you get the idea. I've showed some of the prints before that I couldn't do very well. So we'll just leave it at that. We'll leave it at that. Oh, ooh, those are all independent bodies. Hold on, let me go ahead and combine these really quick. Make it all one thing, make all that stuff go away. Alright, so what's this? Why is this still its own singular body? It should be part of this. There we go. Okay, so let's go ahead and rename this, because I'm actually going to get in the habit of renaming stuff this time. Oh, I'm choking the mind. You can see I'm scatterbrained today. So we'll name that the rotor, stator cap, all that kind of stuff. That looks pretty good. Some guy just started his motorcycle. I heard that. That was loud. And there we go. So that is our 4.5 rotor. Okay, so let's get into some of the more complex stuff here. So I do want to try my hand at kind of designing a rotator here. So do you want to keep that stuff? We're going to do that. Okay, I actually want to flip this around. I like it from this angle instead. Okay, so that all looks pretty good. That all looks pretty good. All right, I just got it. Yeah, I got the thing you sent me. Again, I don't feel super comfortable opening up my Etsy right here to just like show up all the messages I have with customers and stuff like that. So I'm not going to do that on this stream. But I know what you mean. Yeah, about the 2T22 that's in Los Angeles. I knew, like I said, I knew there was one that was in there, but I don't think it was actually part of the CD system. It might have been repurposed as part of the CD system at some point, but I don't think it was actively used for that. Okay, let's go ahead and try working on making this air tube for this. So this should be 43 mils. 43 mils, yeah, 43 millimeters. Go from here. We're basically just going to make kind of like just a plate to start off with. So that's actually should be fine. So go ahead and we'll press pull this plate now. We're not going to join it together. This is going to be kind of its own separate thing. So I know that Fusion will try to auto join it, as you can see right there, but we're not going to join it. We're not going to do that just yet. We're going to make this about 2 millimeters thick, just make it a little bit thicker to have kind of some room to kind of play with here. Not going to join it. We're going to make it a new body. Go down here, and we're going to cut a hole about the same size as the real air tube on the real Thunderbolt. So where is the air tube? Okay, so here's the actual like standpipe that kind of comes up and goes into the bottom of the stator section. This is the whole chopper section. It's kind of big relative to the size of the Thunderbolt. Let's see if I got some more pictures. There's another picture of the 4.5. Did I open that in 2 tabs? Well, what an idiot. I did that twice. Yeah. Don't need that. There's a stator cap. I want to find a good picture of like a side profile. Oh, there's BSP's miniature Thunderbolt. Oh yeah, this is when he was trying to add a capacitor to it. So let's these are 1003s. I don't want 1003. Whoa, that's kind of cool. Sterling Little Giant on a work point? Wow, Little Giants are actually a lot smaller than I thought. That's crazy. Okay, that's not really helping me out a whole bunch. Again, he's working on a 1003. I think this is pretty much the best picture I'm gonna be able to find to kind of work with. So we're gonna go kind of off of that. So I think it's relative to this size, 20 mils is a little small. Let's do like 25 and see where that kind of gets us. If that's gonna look weird or not. Go ahead and press pull it just so I can kind of see it. I mean, 35. Why'd you make it 35? I said, oh, it's a distance. It looks a little big, the way I just did it. It looks a little big, so we're gonna make this actually a little bit smaller than that. So no, we're not gonna press pull that. We're gonna actually go back and change that. So I don't like that. I don't like it at 25, but still looks too big. Let's do 20. Let's do 20 instead. This is also a lot of the way you kind of just do stuff in Fusion, especially when you don't have like set measurements to kind of go off of. This is kind of what we have to do in order to make it look right. Now, for design liberties, in terms of trying to get this to work well, I don't like that this is kind of it's got a very big port, and there's not going to be a lot of volume that I can actually kind of force through this tube in order to make sure it's actually supercharged correctly. So I might actually still go with 25. It's going to be a little bit bigger than we typically see on a Thunderbolt, but I kind of need this to be strong as well. So that is kind of a concern of mine. So I'm gonna make it 25 anyway. And then I'm gonna make the wall thickness of this probably like 3 millimeters, like I typically do, especially because this is gonna be supporting a lot of weight on it, with the weight of both the projector and the whole rotating assembly essentially on the top. So we're gonna go and I'm gonna leave that sketch the way it is right there. So we're gonna finish this sketch. I can press out this hole in the center. And it should hopefully leave this ring along the outside. If it doesn't, I can just go ahead and re-add it. Okay, so it didn't. So I can go back in, re-add that circle just so I remember exactly what size it was. Let's do 25, like I said, and finish that sketch. So now that sketch will stay there, so when I want to kind of add more to it, I can. But let's go and try making the rotator assembly. Well, part of the rotating assembly. So let's go ahead and I'm going to move this up a little bit. This stuff is kind of low. It's a little low to the base plate, or to the base plane. I'm going to translate this whole thing up just a little bit. Give me some more space. Oh, I didn't move the sketch. Oh, that's annoying. Whatever. We'll deal with that. Okay, get that up off the ground. So, and also, for those who actually didn't already know, I actually have printed somewhat of a prototype section of this. So, I do have, like, say, there's a stator cap, which I showed earlier on in the video when I first kind of started off. Let me go ahead and actually go to Streamlabs really quick and actually can blow myself up a little bit here. So I did go ahead and print the stator cap already, so that's that right there. That's been MSLA printed. And again, this is kind of a point as to why my hair looks really stupid. Makes me look like my hair looks like so weird. But anyway, so this is the MSLA printed stator section. This is done with the resin printer, which you can see looks a lot better in terms of detail than that of the FDM printed one. So this is printed with just the regular filament printer, which probably isn't going to show up super well. Let me go ahead and turn a flashlight on. So this is printed with the FDM printer. Which you can see it takes away a lot of detail. It looks really dirty, and I don't really like the way it prints versus this. It is just night and day difference. It looks so much better. Granted, I didn't do a super good job when I took off the support material, so you can see all these like little pock marks and stuff kind of all over it. But generally, it looks a lot better than that of the FDM printed counterpart. So yeah, and the color scheme I'm going to go with my miniature Thunderbolt, because I think that's be kind of an interesting one, because I don't think I've actually seen anyone actually kind of go with this color scheme. Is I'm actually going to make my Thunderbolt red and black, so it's going to look very much like some of the original Siren or the original Thunderbolt advertisements, which I think just looks really good, of having the whole thing essentially black and red, which looks super super cool. Of course, with the striping on the projector, of course. But yeah, and then for those who are wondering, it actually does work right now as a prototype. So let me go ahead and actually put the rotor in the little air tube, and I will put on the stator cap and let you hear kind of what it sounds like as of now. Let me go ahead and kind of move the mic, because the mic it's kind of loud as the way it is right now. So let me do this really quick and show you kind of what the miniature Thunderbolt sounds like as of now. If you're wearing headphones, I warn you right now, you might want to turn them down a little bit. So keep in mind that's without any supercharging. That's just basically the little bit of air that the rotor is actually moving through the Siren. But I'll blow into it and you can hear kind of what I'm getting at. No, it didn't like that. It did not like that. Let's try this again. So even just a little bit of air, it's pretty loud. But I'm going to engineer a blower for it during the stream, so you'll get to see kind of how that works out. Oh, my cables are all tied up in this thing. My cables are all tied up in my headphone cord. Let's get this all kind of untangled really quick. But yeah, that's what I have so far in terms of the actual functional part that actually makes the noise. So that seems to be working pretty well so far, at least. Car crashes and smashes. Hey, what's up, Smarty Pants? What's up, Dad? Yeah, I'm just doing some fusion stuff. You might have seen. This is kind of what I'm working on so far. What I've got designed at least. Looking at the stream right now. Let me go and look at some more of the comments too. Okay, it's Siren Guy 911 says it's arm on just like a metal pole with no basket, no legs. It's just standard all pole. Yeah, exactly. It's good. It's basically just sitting on just a pole. Matt makes machines. Yo, are you ever going to share or sell your 3D files? Maybe at some point. I'm probably not going to do it on Thingiverse because Thingiverse has a tendency to just basically unlicense all of your stuff. Because it basically gets put into a Creative Commons where your files, as soon as they're out in the public domain, they are no longer considered yours. They are considered like anyone's files. They can print them, they can sell them, they can do whatever they want. And I spend a lot of time designing my Siren, so it's kind of one of those things where I don't really feel like just kind of putting them all out there. At some point, I might start selling off or making my files public for some of my old model Sirens, like say like the Model D or something like that. I'll end up making those public because I don't really sell those anymore anyway, and they're not that hard to assemble, so I might end up doing that later on. But as for like new designs and stuff like that, I'm probably going to keep those kind of close to my chest because they take a long time to design. You should make a 5 port 5.6 4.5 3.4 and 4.6 rotor. I definitely can. That's kind of like again, if you're just not coming into the stream, that's kind of one of my intentions is to eventually make this whole entire Siren kind of somewhat customizable. In terms of at least in the regards of port ratios. So it'll have different port ratios. Like of course, like I was saying, this one is currently 4.5, so it's a 4 port on the bottom, 5 port on the top. So it has that kind of different tone to it. But I will make him have different ports at some point. The 3.4 will sound like a 912 port, and the 4.6 will sound like an 812. Yeah, exactly. Especially at this kind of rotor speed that it's gonna be spinning at. Siren Guy 911. Yeah, I should make a meme with the cat standing up within the 500 SHTT in the Los Angeles pole, and the siren is falling down because your cat knocked over. Yeah, that would kind of make sense. I mean, I probably could like edit a photo to make it look like that because of my 500 is destroyed because of my cat. Matt makes machines. You should share your files on printables, and it's a lot more secure. I don't know. I probably might. Like again, like I said, there's a couple of designs that I really don't think I'm going to be ending up like trying to sell again, so I might just end up giving them away. So again, like I said, the Model D, for example, it's a cute little Siren, but I really don't need to make any money off of it. It's just basically and those who are wondering, pretty much the money I make from selling these Sirens is pretty much just to help support me make them, and like it helps support me putting time into designing them and all that kind of stuff, and it just makes it somewhat, it helps out the channel is basically the best way I can say it. But yeah, stuff like the Model D, I might end up just putting up on like some kind of file sharing site so people can kind of have it themselves. Don't share your files, lol. Yeah, I kind of don't want to share my files because again, they're just such a pain to make, and they usually take hours. So it's a lot of time sunk into these things. So it's a not kind of one of those things I really want to just give away. It's like having rights to a song, for example. It's like having rights to a song and just like making it public, and then anyone can use it, and you also just you don't make anything from it, which is like normally fine. Like I'm not really super into trying to make money off of it, but like it's just one of those things where I kind of want to protect my intellectual property. Um, but yeah, or there's probably could be even some way I can actually watermark all my parts so that basically, even if you do download it, it very clearly looks like one of my parts. I don't know. Are you going to attempt to make a attempt at making a 1003. Yeah, at some point I'm going to make a 1003. It's going to be based off of basically this design. I haven't thought of a way of actually making the solenoids work because I have to make really, really small solenoids in order to actually make it do high-low. And then I also would have to make an RCM3 in order for that to all work correctly. So I'd have to actually kind of like design a either electromechanical RCM3 or do all the RCM3 stuff based off of like say Arduino. I could use like an Arduino like Nano or something really small Arduino. It wouldn't be that hard, but you know, just things to kind of consider. So let's go on and start kind of working on this rotator section. So I do have the air tube coming up from the bottom. I have it set to currently 25 millimeters in diameter. I can go ahead and remeasure that. So I want to make sure I'm going to have enough air getting through this because I want to make sure I maintain static pressure or peak static pressure at the actual throat of the horn right here, so that's at the stator cap. I do have a manometer too, so I can at some point when I actually kind of get this stuff kind of roughed out and designed, I can actually test for pressure to make sure that the pressure is going to actually be adequate. And I can kind of fine tune how much pressure I want to really feed the siren in order to make sure that it's going to sound right while not bogging down the motors and stuff like that. So again, we have this here. I'm going to go ahead and back and re-add that little sketch because for some reason that sketch wanted to move way to the bottom. So I'm going to put that right back over there. I'm going to make these sketches go away because I don't want these down here. These are in my way now. There we go. Make that sketch go away. All right, so let's go back up here. We're going to go and start off with doing some more of the other stuff. So get rid of construction planes. I'm not going to need those. And Matt Makes Machine said, will the chopper level be able to be changed? Yes, it will. It'll have variable chopper levels and as well as variable rotator speeds. It's not going to be done mechanically, so you're not going to be able to get into the rotator box to change the speed by changing a belt like you would on the real Thunderbolt. As everyone knows how the rotator works on that, so you got your variable belt positions down here on these kind of these tapered pulleys. But I'm not going to be doing that. It's not going to be a belt-driven rotator. It's basically going to be essentially like this top section you're seeing right here with this very large bowl gear that's basically going to be rotating the entire tube itself, and the rotator motor is going to stick down from that. So very much of the same way that the alerter rotator worked, where it's basically just the motor coming off the bottom to rotate the thing, or if you want to even look at the 500, for example, it would pretty much look just like the 500 too, the 500's rotator. So it's basically going to look somewhat like this, kind of in the rotator cabinet with the drive gears to actually operate it. But the motor will actually be variable speed, so you can actually set it yourself. That and also the blower speeds can be set to. I still haven't kind of thought of what idea for the blower I want to go with. I think I'm kind of decided on going with centrifugal blower, just because I'm making a roots positive displacement type blower, like a screw style supercharger or a lobe style supercharger, is just not really efficient at this kind of scale to get not only the flow rate I need, but also the static pressure I'm going to need to have to actually make it work right, just because the tolerances just aren't there with 3D printing. Even if I MSLA print it, it's just not going to be sufficient enough. So I'm pretty much most likely going to go with more of a centrifugal route. And just working on a centrifugal blower instead. And I do actually, in fact, have my prototype kind of centrifugal blower I was thinking of for the 1000, for the 1000T right here. So this is a simple little blower design I had designed. This is kind of in between, like more of an intermediate pressure. And this is pretty much what that looks like. So this is the blower I have designed. Works well enough, it makes enough volume of air at a decent enough static pressure, but I probably will end up actually having the impeller speed be raised. I'm not going to be using the RM130 motors that I've been using, and instead we'll probably go with like something like a 380 size brushed motor that'll actually be 12 volts. So the whole system for the miniature Thunderbolt will be 12 volts based rather than 5 volts based. So it's not going to be running off of USB. It's going to be using its own dedicated wall port or like wall adapter. Just because the blower really is going to be the biggest hog. It's going to be pulling all the power, so that's kind of one of the things I have to kind of consider. So I'm going to go ahead and go make this offset plane. We're going to start kind of working on the rotator section now. So I want to have it come down just at least a little bit. About right there looks good enough for me. I want to make sure this is going to be somewhat accurate to the real one. I wish there was a better picture of just the cabinet and everything. I do have pictures that I've gotten from Eden, but I'm not going to be trying to rely on those very much. So here we go. It's a pretty a pretty good kind of all-encompassing picture right there of like what the rotator cabinet looks like in terms of like height and everything like that. So we're gonna go off of that. It's kind of sock. This is from Vanamon 2's channel, by the way, for those who are wondering. Props to him. You can find him at the civildefensemuseum.com. That's basically his website where he's got all this kind of stuff and there's a lot of this data that I'm kind of pulling from here. Matt makes machines. I'd love to see you make a Cyclone or a P50. That'd be a lot of fun. Definitely. I'm probably working on some more ACA stuff later on. Siren Guy 911. That is so funny. It sounds like a Model Q had a baby with the Thunderbolt 1000. Yeah, it's rotating at a really high chopper level if you want to think of it that way. That's just direct voltage going to the thing itself. Let me also go ahead and adjust my Streamlabs because I realize I'm also still super gigantic. So we'll go ahead and move this back down a little bit. Make sure I'm kind of out of the way just a bit here. I didn't realize I actually messed up and had that super big. So yeah, this is, yeah. So anyway, we'll get away from that. I realized I was kind of just talking to myself. Matt Machines, I'd love to see a Cyclone 120, 125, a P15, a P50 in the future. I'm definitely going to make a P15, a P10, based off of the Rotor design, but I'm also going to stop kind of talking so much and go more into the actual design process. So this air tube, I actually can kind of make this as long as I want eventually, so I might as well just go ahead and press pull this part right here, right now. And I can always cut it down shorter when I really want to. So I can make it super long right now to kind of reach down into the actual rotator section. So we're going to do that. It is going to be a long air tube because once it gets inside, I'm actually going to have a bearing to pretty much support the bottom of this. So yeah. Oh, good. I thought you were hiding things to tease us. MSP. Yeah, I didn't mean to do that. I just was an idiot and wasn't paying attention. I kind of got stuck in just my own little world. So yeah, so we're gonna go ahead and join that right now. We might as well just keep it there. And then let's actually design, I want to design the actual, this weather ring right here, this little weather shroud that helps protect water from going down into the Siren itself. So this shouldn't be super hard to model. I could probably do that just using just the loft tool. So let's try that right now. We'll go in here, we'll sketch a somewhat large circle. Make sure get all this stuff out of here so I got just one thing to focus on at a time. So I can probably come in here. We're going to make this part will be FDM printed, so I'm going to be basing my tolerances kind of off of that. So 25 is the diameter of the air tube itself, so we're going to go 25.2 probably, just make it at least a little tight. So if it's a little tighter around this thing than normal, so we're going to do 25.2. I think would be pretty good for what we're trying to do. I might actually even go to 25.2.25. Make this a little bit bigger. Because I don't want it to be super tight on this collar here. And then we'll make this thickness itself a little bit bigger. So it's 26. That's coming off about 1 millimeter. So let's do 20. Let's do 27.25. So 27.25, which will bring us off exactly 2 millimeters from that inner ring. So that gives us that face right there. So let's go ahead and get rid of this air tube now. So I have this sketch. Let's work with just the sketches right now. And we will complete that sketch and go down. We will do another construction or another offset plane off of this sketch. So I can kind of come off of this and go down a little bit so I can get the profile of this kind of rain collar just a little bit better. 10 millimeters. It goes down kind of deep, so yeah, it does go down kind of deep. Let's just say 13 millimeters. Yeah, let's just say 13 millimeters, because there's the air tube and the motor tube. I realize that I'm sketching this pretty far down, but I'm going to scoot it up later on. Okay, let's just say right there for right now. That looks pretty good, 13 mils. Okay, so 13 millimeters down from that, and which is going to be the height of the collar itself. And we'll come in here, we're actually going to sketch how big the collar is going to be on the bottom section of that circumference, or that diameter, I should say, specifically. So this is 26, this should be 27.25, I believe, correctly. 25, yeah, 27.5, 27.25. So let's come off of this about, because I want to have about another 2 millimeters in between that to actually make the collar, to make the space the tube is going to fit through. So let's go about right there, 36, let's say 36. We'll finish that sketch as well. And now this will allow us to kind of come in here and actually do the loft tool, of course. So loft between these two, that did not go where I wanted you to. Let's go and loft again. I wish there was a shortcut just for the loft tool so I didn't have to keep trying to run back to it. Okay, so we're in the loft between this outer one and this inner one. Okay, so now, of course, that's very triangular. We're not going to make the air tube, we're not going to make that collar triangular for obvious reasons, because that doesn't look right. So what I can do is do direction. Ooh, other direction. Connect that one, and we'll do just one tangent. There we go. That's more what I wanted to do. Okay, so this should allow me to kind of make this bow out a little bit. We can also actually change the takeoff weight down here to kind of make this go out a little bit further. So let's do like 1.5. Well, let's do 1.6 and see where that kind of gets us. Shoot, I don't want to go a bit more than that. Let's do 3. Whoa, whoa, too much, too much, too much. No, 1.6, it looks close enough. Let's do 1.9 and see where that kind of gets us. Look back at their reference image here, so it does have a bit of a small, goes up, tapers off, goes up, flares out, because this whole thing is made out of spun steel usually, or spun aluminum. Same way you make like salad bowls and stuff. So this has, looks like it has a pretty heavy takeoff weight out to right there. This collar is also not super important, so I kind of want to make sure that that's clear. I don't need to save that. Yes, don't save. Again, this is the blower, the kind of the blower design I have so far for the Thunderbolt. This is going to be a centrifugal blower, but I'm going to make it a lot more high pressure than what this one is, because I learned that this is not enough. So where's the collar for this Thunderbolt? Slip ring to air tube mount, air tube collar. There it is. So there's the collar that I have for this Thunderbolt. The old design, which again is very similar to the collar I'm pretty much making right now. Very much so. Go back, keep flip-flopping. So that's kind of the collar design I'm thinking about. It's very similar to the one in the old design, but I know the one in the old design worked well, so it's not too much of a concern of mine. And really, the collar is just like a small accent piece. I don't think it really matters if it looks super, like, ridiculously accurate, but we'll try our best. So here is our lofted piece. We'll go in here to use the shelled command to actually kind of shell this in. Make the thickness 2 millimeters. That's kind of what I want to go with. Ooh, that looks thick. Ooh, that looks really thick. That might be too much, actually. That might be a little too much. Might be a little too much, because I want to make sure that this is going to have enough space in between to actually make sure that it's going to be strong enough for the basically the top bearing to carry all that weight. So that might be a little too thick. Let's do 1.5 millimeters instead. Let's try that. Ooh, not 21. Not 21 millimeters. That is super thick. Let's do that. Let's do 1.5 and see how that kind of looks. That looks a bit better. That's still thick, but it gives me more space. So we're going to go with that. Let's say that's good. And we're going to get rid of this. Come in here and press pull that shape. Did I really mess that up that much? I don't think I did I? No, that's still good. That's still good. So, all right, so I'm going to go down to this bottom face, sketch again, because it made that sketch go away that I previously had because I did the lofting tool. So, 25, that's right, and I made this 25.25 to give us enough tolerance to kind of come off of this back. Now I can get rid of this air tube, come in here, press pull this, get rid of this center section to make the collar actually hollow now. And that should be plenty enough to actually, whoa, this fusion had a seizure there for a sec. So that should be plenty to actually allow us to slip this whole collar up and down while it's still being somewhat tight. From this angle, it looks like a Model L. It kind of does. Because I have the collar like way the hell down on this tube too, so it looks really weird. But now I need to add some of this profile back to it because the collar does have this like little lip that kind of comes up from the actual flared portion. So we'll come up here, do another, actually probably just press pull that. Oh, no, I can't. Never mind. I tried. Sketch this. We're just going to sketch another circle off of this. Come in here, go to that edge, go back to the center, that center ring. Come up here, and we'll make it up. We'll make it go up like, I don't know how much, like that. 4, 5, 5. That's probably too much. Let's do about 5. Why not? Hmm. 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 Yeah, screw it. Let's do 5. 5 looks good enough for me. Again, this is just kind of just its own little accent piece. It's not going to be super, super vital to the function of the Siren. It's really just there to keep water from going down the center of it. So let's go ahead and move this up, slide up the tube so it looks a bit more accurate to what we're kind of working on here. Add that stuff back. Yeah, that looks fine. That looks fine to me. It does get really close to the bottom of that motor tube thing, thingamajig. I'm gonna say that's pretty good, probably right there, because it gives us just enough. That looks pretty good, right there. 15 millimeters down from the top. Yep. So we're gonna keep it there. We're gonna say that part's kind of pretty much done. But now we have to kind of work on making our rotator cabinet. So this is the part that I'm really horrible at because I made my last rotator cabinet look like absolute dog. So let's do another offset plane off of this. And let's move it about halfway up. Why did it slice on that side? That's so frustrating. So let's move it about halfway up a little bit. Yeah, it's about midpoint right there. To start kind of making the actual rotator cabinet. So I keep forgetting. It's annoying because the camera's viewing angle is like really low down, so I have to like. But in order to see the screen really well, I have to have it angled up. So it's you keep seeing just my head, and like none of my torso. But that looks pretty good. So we're gonna keep this. I'm going to keep that there, and then we're going to go in and actually get rid of this tube now because I don't need this intake tube, or this air tube. I'm going to rename that also so I don't forget what it is. Air tube. Air oob. Misspelled. Air tube. So there we go. So we got our air tube there. Alrighty. So now we'll come in and see what we can kind of do for our rotator panel or our rotator top. So from this offset plane that I just basically put in there, we're going to go in. We're going to do a triangle, I mean a rectangle. So we're going to just go here, go to create sketch, sketch off of this plane, and I should be able to actually do a center point rectangle. Yeah, there we go, center point rectangle. This will kind of allow me to really quickly just like whack out a rotator cabinet, but I kind of want it to look appropriate to the real size ones. So, and it kind of sucks because I'm gonna make this rotator cabinet, but it's not really gonna have a whole bunch going on in it. Because I just don't need a rotator cabinet this big, because it's not going to be belt driven. So there's no point in having a super, super big rotator cabinet. I think that looks pretty good. So about 100 millimeters by 70, which is going to be, oh my god, this thing's going to be huge. Once I actually print it, this thing's going to be gigantic. Which looks so small. It looks so small relative to the head. Oh, this is going to suck. This is going to barely fit on my printer. Oh my god, it's gonna barely fit on my printer. Oh, this is gonna be horrible. This is gonna be a long, long print when I actually make it. Oh boy. Okay, so let's. It's gonna be so big. Okay. Well, it has to be bigger than that because it's gonna make it more to scale. So let's go just a little bit bigger than that. I'm gonna get rid of that sketch. That's someone's chopping wood outside. Sounds like. Get rid of this analysis. Let's go back to doing that center point rectangle. Oh man. Oh man. It's really big. Oh, it's really big. This is gonna be horrible. This is gonna be like really, really hard to print. I'd be surprised my printer is actually going to have enough resolution, I mean, enough size to actually print this. I think my printer is like I think is 120 by like 120 by 120, so it's not gonna be, it might be very, very close to being too big. I'm maxing my printer. Even unless I print it vertical, but if I print it vertical, it's also not gonna look very good. So that's kind of what our shape is for this. I'm gonna go ahead and press pull this just to see kind of what it would look like once it's kind of completed. That's too long. That's like a cabinet for like a 1003. I mean, that's close. That's close. It's a little more squatty. It's a little more squatty than I really thought. Let's make it just a bit squattier, a little bit more stout. Nope, I actually think I had it pretty good the way it was. Let's do 65. Let's see what that gets us. It's kind of in between the sizes it was at. That's 66. 65. So it's a little bit bigger. I'm comfortable with that. I think that looks fine. Yeah, I think that looks fine. That looks pretty good. So we're gonna stick with that. I'm gonna assume we're gonna make this. We're gonna try to make this rotator cabinet 65 millimeters tall. Oh my God. I'm just I'm internally cringing because I know it's gonna be a real pain to print, but whatever, man. Let's just do it. Let's go with 65. That's gonna be big, but then it's gonna be, like I said, a lot of empty space. But why not? Whatever. It gives me a lot of empty room that I thankfully don't have to fill with a whole bunch of filament. So let's say 65. So I'm gonna cancel that, so I know I can just kind of keep that size in my head as to how big we're really gonna make this thing. So now we'll get rid of this this collar. Where's the collar? There it is. Rename this again so I can make sure I know what this is. Rain collar. Oh, God, man, I am horrible at spelling today. Rain collar. Okay. So we'll get rid of that. Go away. There we go. Okay, so now let's go ahead and actually press pull this and dictate kind of what thickness we're going to go with for our rotator cabinet. I kind of want to make everything, oh, way too thick. Way too thick. I want to make the top and the bottom of the rotator cabinet kind of like the thickest pieces because those are going to be supporting the lateral load of the whole horn wanting to kind of pull the air tube down at an angle. So there's going to be basically the top of the rotator cabinet. Say this portion is the top of the rotator cabinet. This is basically going to support that air tube and act almost like a bearing. So I want to make sure that this is going to be thick enough to actually support all of that. And I might even put some cross webbing on the top of this panel that you won't be able to actually see in order to make sure this is going to be reinforced. Now 3 millimeters is kind of thick and it's going to be a lot of filament to print that and it's just going to be a long print if I do that. So let's do 2 millimeters instead. 2 millimeters like everything else kind of pretty much is. And we'll cut the hole for the air tube so I can actually see. Let's cut this hole for this air tube and then we'll add the reinforcement later. So I'm going to make this a pretty tight tolerance. I'm going to make this, I mean, it's going to be just not as tight as the collar, but I need to make it have enough slip to actually kind of work. So the air tube's diameter is 25, so my normal tolerance to make a tight, snug kind of fit would normally be about 0.25 over whatever my diameter is, whatever my measurement is, to add basically to get my tolerance, because basically based off of what the printer is doing. But instead, we're going to go probably at least a full, excuse you, bless you, honey, it's my wife. Let's do 25.5, so about half a mil of space, which should be more than enough to give us some room to kind of have this thing be able to rotate freely without it being super, super tight. So let's do that. We'll get rid of the air tube now that we know this diameter, and then we can come in here, press pull this, and make this hole. And never use the hole tool. Don't ever use the hole tool in Fusion, unless you're actually like trying to machine something, because it's pretty useless. You want to know why the hole tool is useless? I'll show you right now. Oh, thanks. I put it way over there, and you have to like drag the hole and try to get it to line up right, and it's stupid. Yes, you can countersink and all that kind of stuff, but it's useless. Don't use the hole tool. That's my little top tip of the day. What wouldn't work in Fusion? Don't use the whole tool. Then we'll come back over here. We'll go ahead and we'll sketch this out. So I know I don't have a whole bunch of space to kind of work with in terms of where this rain color is, because I have to make sure I'm still gonna fit within that. I probably should have moved the rain color up a bit more. Let's go back real quick. Let's undo this sketch. We're not gonna sketch right now. So let's just say that sketch is over with. We're done. So yeah. Let's go ahead and move this down just a little, just a smidge, to about where it would sit on the Thunderbolt when it's actually assembled. Wow, that tube comes up so far. Okay. That tube comes up really far. So let's go down like right there. Yeah, that looks good to me. I'm not gonna make it any more than that. And then we'll come up here. We'll actually cut, or then we'll sketch this now. Make this. I don't know why I brought it back. Get rid of the rain color. So let's go ahead. So this is what I said. Yeah, 22.5. So let's go. I want to make this tube support thickness be a little bit thicker than that. So let's go about 27, make it 2 millimeters as well. So about 27.5 again to maintain that same consistent thickness. So 27.5. Come here, press pull this, please. Thank you. Press pull this up a little bit. Make sure I bring this air tube back and bisect it so I can see where I'm at in terms of how far I can go up before I start hitting the collar. That looks pretty good. That's pretty good right there. I'm a little concerned that I'm going to be making this air tube a little thin. I mean, not the air tube, but the actual top of the support a little thinner than I really wanted it to. I might just bite the bullet and make it 3 millimeters thick, which is going to be really thick, but I need it to support a lot of weight, so it's kind of required. Yeah, let's make it thicker. This is going to take a lot of filament to print this. This is going to take a lot of filament to print this prototype. So yeah, this is going to take so much. Again, for those who are probably just now tuning in, what color scheme I'm going to go with the Thunderbolt is because this is going to be dictated not by the color of the filament. Well, it will be, but I'm not going to paint this Thunderbolt, so I'm not going to weather it or anything like I did with the Chrysler. So this whole thing is probably going to be printed just with the filament colors. So I'm pretty much almost out of gray, and I'm really getting the gray filament I do have for making poles for the Los Angeles system and also baskets and stuff like that, as well as like stators. And I don't have a whole bunch of it left, so I don't want to spend the rest of my filament making a prototype. So I'm going to be printing this whole thing in both black and red. So it's going to be a black and red Thunderbolt, which is going to be kind of interesting. Again, going after like one of the old Thunderbolt advertisements, which people have seen. So let's make this a bit thicker than I was going to go the first time. So it was, what was it, like 25.5. So let's go. Oh, man, I don't want to, but I have to. Not much of a choice. I don't want to make it super thick. I don't think I think I just have to. Okay, whatever. Let's just do it. 28.5. She's gonna be a little tick. Okay. Oh yeah, bisect it again so I can see. Okay, God, that's gonna be a really thick top of this cabinet. That looks pretty good. That looks pretty good. And I'll print like little assembly spacers so that when I actually do put the tube together, I can actually make sure these are all spaced out correctly. Let's say about right there, just to make sure it's got enough of an overlap. And go off from what we have so far. Rotor, air tube. Don't need the bisection. Get rid of that. Okay, so we basically have the top of the rotator cabinet right now, so that's gonna be pretty good. I'm fine with that. Tornado Siren Rubik says hello, and Andy DC looks pretty good so far. Can't wait for the end product. Oh, wait, hold on, that Andy DC? What's up, man? I know I've been like basically dead on Instagram for a long time, but yeah, good. Glad to see you join the chat. I don't know where Aaron is. But yeah, for those if you're wondering why I haven't been in the Instagram chat for a long time, is because for some reason my Instagram is just like not sending me notifications, and I also just am so busy, and I, in fact, kind of just like barely use Instagram anymore. But so that's why I've been missing in action. Um, so yeah, this looks pretty good. It's a great cross section. This looks like there's gonna be just enough space to kind of get air up in there. I don't like that's gonna be running like right into the bottom of the motor, but I guess it'll help keep the motor cool. So this looks pretty good in terms of what we're gonna be doing for this cabinet. It's a little thick, like I said, but I don't have much of a way to get around that. You know what? Let's just check. Let's just check before I get too in depth with this to see if it's even gonna fit on the see if it's even gonna fit in this. Let's just name this really quick. Rotator cabinet top. Let's just name this just really quickly so I can know where it's gonna what it's gonna be named. So it'll just drop in there really quickly. Thunderbolt, yes, okay. Go to my desktop really quick. Oh, I've got so much stuff open. Let's go to Fusion, or not Fusion, Prusa, and we will slice this really quick just to see how it's going to fit. New Thunderbolt. I'm worried it's not going to fit in my print bed. Oh wow, okay, never mind. Never mind. That's not a problem at all, actually. Wow, really? Really? I think okay, that's actually quite pleasing to see that it fits in that just fine. All right, just want to double check because I forgot my print bed. I guess I forgot my print bed size, but that looks fine. So that looks pretty good. I don't know if I want to focus on making the entire like cabinet sealed. I think I do want to make the whole entire rotator cabinet kind of sealed so that no one can get into it because I really don't have an intention for anyone to actually try to get up into it to try to mess with things. Because it's not really a primary focus of mine, and I'm going to probably work on the rotator a little bit later, where I kind of really go in and design the gears for it and all the kind of like mounting for the rotator section, but that'll come later. But I guess we might as well kind of try working on making it at least look like a box. So what I'm thinking about doing is having the whole entire rotator section be basically just like a box that's got all four sides on it that are basically welded to it so it doesn't come off. And then the way that it's assembled is that the whole rotating section actually slides in from the top. So this whole thing will basically just be retained. So I'll probably actually put even like a retaining ring that I'll actually have to glue onto that. Probably right here for the air tube to make sure this actually stays there. We can base it off of this. We'll base it off of the rotator panel because it'll fit just fine. So we'll go in here, manage my gaps here. So that's the rotator cabinet. We'll get rid of that. Get rid of the rain collar. Get rid of the rotor. Get rid of that. Get rid of that. So I have just the air tube. Okay. So now I can see what I'm working on. So 25 millimeter diameter. So let's do 25.25, like I said before, to make sure enough of tolerance to get in there. So that's gonna be there, and then we'll go and we'll make this basically whatever measurement I want. It doesn't need to be super big, but let's just do at least 2, so I have some kind of something to grab onto when I'm actually making this. Oh, why not? Make it 3. Make it 3 millimeters. And we'll come in here, press pull this, including this section. There we go. So now I should be able to kind of come in here and we'll make this actual like retaining ring, which will essentially be here to keep the whole air tube and top section of the Siren from actually just like slipping out of the rotator cabinet, because you wouldn't want that to happen for obvious reasons. Because then the whole thing would essentially fall apart. So once it's assembled, it would look like that. That's pretty close to the top of the rotator cabinet, but that should be all right. Okay, new body there. So we're gonna make this a new body so it doesn't just like that. So I can actually get like remove it from this portion. So we're going to name this the air tube top retaining ring. All right, so make sure we can actually keep that all together. Dude rocks. Oh, there we go. I was just fucking asking where the hell Aaron was. Apologize for the cursing. I forgot this is my Christian Minecraft server. Um, Eden still hasn't finished where you left off with the mini model 120. I have an Ender. Oh, you got a 3D printer now. Sweet. I have an Ender 3 V2 Neo. I got a few months back, but still trying to get it dialed in and print just right. Yeah, I mean the Enders are actually pretty good beginner printers. I'm glad you went with an Ender, not like a CR10, because Enders are, I mean, they're all clones of the same thing, but the Ender line is usually a bit more better when it comes to typically like working with it. I found at least when the ones I have worked with. But yeah, that's cool. Yeah, I know that Eden's been like, I don't know what Eden's been up to, but yeah, I mean, when I was at it when I was there, which I also forgot to tell you that I was even there. I completely forgot that I was supposed to go and hang out with you too when I was back in California. I got so caught up with everything, and I was just like, I was honestly, I barely had enough time to even hang out with Eden. But yeah, when I was at his house, I realized he just had the model 120 like just sitting in his room, and I was like, dude, I thought you were gonna do something with it, but no, it's just sitting there still. I think I told him to give it to you when I had the chance, so you could kind of work with it. Um, but yeah, cool. It's cool to see you have your own 3D printer now. It'd be really cool to see what kind of stuff you go into designing if you start kind of like making your own models. Because you can make some pretty cool stuff, man. I would love to see like what you like, because I knowing you and like knowing how much you really care about the Model 120. I mean, just as much as I do. I mean, more than I do, obviously. You're like the guru when it comes to it. But like seeing you being able to spend some time and actually make the like model the 120 yourself, like the amount of detail you put into it, I mean, it'd be super cool to see. Um, Anyway, so let's go ahead and continue making the rest of this rotator box. I'm going to come off of this plane. I said it's about 65 millimeters. Kind of looks about like the right height for it. Again, like I said, there's going to be a lot of empty space in this thing, but just it's going to be this par for the course. There's really not much I can do about that. So I think that looks pretty good. 65 millimeters. Let's go ahead and make that, so solidify that a little bit. And then we will come down here, do our center triangle. Actually, I don't even need to do center triangle. Center, center rectangle. Go down here. We'll basically just model the bottom of this really quickly. It's not going to take that long at all. Press pull this. Make it, I don't know, like 3 millimeters thick. Three, whatever. Like, let's do -3 actually, so it makes it go up instead of down to add to the height. I don't want to add any height to this thing. It's already feeling super big. So let's do like -2. It doesn't need to be super thick as compared to the top, because again, the top is carrying so much weight. And there's going to be a bottom bearing for this, of course, obviously. So let's go with that. That's pretty good. These two cabinets should be the exact same size. Let me just double check because I know I'm an idiot and probably would have messed that up. I would have found some way of doing that. So that looks pretty good. That's pretty good. So now we just want to go and wait a minute. Let me think for a sec. I know, dead air, dead air. I just gotta think for just a second on how I want to make this actually latch into the top. I'm also gonna have to put a hole in the bottom at some point to make sure I can actually run the wires into it, because that would really suck if I just did all of this and you couldn't power the power the thing. Dude Rocks 5539. He's been busy with his music and his bands. But with the Ender, I think I need to adjust the retraction speed. I've been procrastinating with getting everything all dialed in. Yeah, the Ender 3, I believe, it uses a Bowden extruder rather than like a direct drive like the Prushas do. So the retractions can kind of be a little annoying because you have like that super long, basically like tendril of filament that's coming from the actual drive motor for the extruder. So I know that's kind of a pain. There's a way. I think there's actually test prints that help you dial in your retraction speed that you can actually kind of go through, and then you can really fine tune it on like whatever slicing program you use. I think like with the Ender 3, I think their default slicing program they give you is like Cura, I think. I haven't used Cura in so long because the Prusa slicers work so well, but I think you probably could honestly even do the same thing in Cura with Prusa slicer. So you might want to try using Prusa Slicer and seeing if that helps, because I know that Prusa Slicer is usually really easy, and usually you can kind of go in here, you can actually customize like what printer it thinks you're using. So like, see, you got add or remove printer. You can actually come in here. I think you can actually dial in like your actual print bed size, your what kind of extruder you have, and you can actually kind of just do a lot of the stuff with Prusa Slicer. Again, just because Cura is just kind of a pain. But yeah, it's cool they have an Ender 3. The Ender 3 is actually was the printer I was going to get when I first started out. But yeah, let me know how it works. I'm really curious about it. I've seen a couple reviews for it, but nothing beyond that. And also, for this is specifically for Dude Rocks 5539. So if you wanted to see the what the actual design of the 120 looked like, I've shown this on other streams before, of course, but I'll go ahead and pull it up really quick because I just have it. So this was as far as I got with the 120. So this was pretty much what I have. I'll go ahead and do an analysis really quick. I did not do an analysis. That's annoying. Oh, you can also do center of mass. That's cool. I didn't realize you can even do that. Let's do a section analysis really quick just to show Aaron. So this is what I had for the 120. You can see like all the waveguides cut through and everything like that. So yeah, there's the deflector up in the center, the rotor kind of out here. This is still the 4-port rotor. I do have the 5-port designed on another section, but this was the prototype that had the 4-port. And there's of course there's the Paxton blower down the bottom and all that kind of stuff. But yeah, so that's what I have so far. At some point, I might actually be able to just give you. I actually might be able to find a way to just giving you the files I have, Aaron, for the 120. Because I mean, after all, you gave me all the blueprints for it, so it's not like it's my design. But like, I can give you all the files for it if you promise not to share it with like anyone else. Because it took so long to make this, dude. You mean you were there? This thing took like months to design. Um, but if you want, I can probably actually just give you the files so that you can kind of pick up where Eden left off if you like start designing like your own parts. I think that'd be really helpful. Do Rocks 5539, yeah, it's Bowden. The main issue is what it's been doing is that the nozzle was dragging against the prints. I'm still not familiar with 3D printers a whole lot. If you have got if the nozzle's actually like going against the actual part you're printing, it's probably not actually retractions. It might be that you have to adjust your bed level. But yeah, I'll get back to you on that, Aaron. I'll send you the 120 files because I know that those, like I said, they're yours. Oh, that's right. Yeah, you can text me. I forgot I have your number. Where are you? I'm not seeing you on here. Is that why I haven't seen any of your messages? Is because it's just like backlogged so far on my phone? I've got so many messages on here I gotta delete. Maybe I have. Maybe that's why I haven't seen your messages. It's because they're like backlogged on here. Yeah, let me go in here and just clear some of this stuff out really quick. Just because I've got so much stuff on here. I just want to clear it up so I've actually got room. Like, I'm trying to find out where you messaged me on. Maybe it's I keep getting because I have so much like spam that's like sent to my phone, so it's just like there's just like a gigantic like wall of text. Let me actually look you up really quick. Or did I not? I might not have added. You might send me a text really quick, Aaron, because I don't think I think I might have not actually added you as a contact. I just have your number on here. So if you send me a text really quick, I can go ahead and make sure I have that there. But yeah, I'll probably like email you the files for the 120. I can definitely I'll do that. I'll probably do that like later on today because I'm gonna be kind of busy today. Let's get back into this though. This is the old Thunderbolt. I'm like, what the hell? It doesn't look right. Okay, so I think what I'm going to do is I'm actually going to have to make this slightly oversized on the bottom section. Just so I have enough space to kind of add a lip to give me the walls of the cabinet. Okay, there we go. Thank you, thank you. I was like wondering why the hell I couldn't find it. Okay, I'm gonna add you as a contact really quick. I don't know why I didn't add you as a contact before. I thought I did. Yeah, alright. Yeah, there you are. There you go. So I sent you a message, Aaron, so now you can, now I know who you are, or where you are. Disregard the, disregard the text message. Um, okay, so I'm actually going to have to make this bottom plate a little bit larger so I actually can fit the lip that's actually going to hold on to the bottom of the rotator cabinet. So I'm going to have to make this at least like slightly larger than what I really want to do. But I'm just going to have to kind of just roll with it. So let's just make this, let's do center rectangle again, which just really helps with alignment, basically. So this is 80 by 120. So let's go up a little bit to give me some kind of room to add a lip. So 82 by 122, that looks pretty good. So we're going to do that. So I have a 2 millimeter lip on either edge, basically that I can kind of work with. So yeah, we'll go here. We'll go and press pull this. Press pull this whole thing, which yeah, okay, it should automatically press pull it. So now we're going to do a negative, so it makes it go up instead of down, negative 2 millimeters, make this whole thing 2 mils. I remember the top plate is actually 3, I believe. So negative 2 millimeters, we'll do that, and then I should be able to actually pretty much just mask this top over it. So let's do another sketch. I can do two-point rectangle this time. And now we're going to go, it's going to flip me up that way, but I'm actually going to do it from the bottom. Then I'm going to make this bottom plate I just made disappear. Then I'm going to retrace, oh, that's stupid. Hold on. Now I'm going to retrace the outside of this to give me the right dimensions again, if it wants to not fight me. There we go, so I can finish that sketch now. So now, when I get rid of all this junk on top, get rid of the retaining ring too. So now I get rid of all that junk on top. I should have a sketch perfectly placed on top of this that allows me to actually get this edge and press pull that entire edge. So now I actually have a hollow box. I could have actually just made the box and then used the shell command to do that, but I like doing it the long way because I can kind of actually like see what it's doing. I just have more, I don't know, I like having a sense of more control than I normally would with just doing shell commands. So, and granted, this is 2 millimeters thick, which means it's not a thick rotator cabinet, but I also really don't want it to be super thick, as it's going to be, it would be a ridiculously large, or a really expensive print in terms of how much material it would consume. So I just didn't want to do it that way. So this is a rotator cabinet top. Let's go ahead and bring this pretty much all the way there so I can see how good it looks. That looks pretty good. I'm not joining those two, so it's going to be a new body. That should be pretty good right there. Yeah, we're going to do that. Okay, new body. And now if I didn't do any adjustments to this, that means this whole entire rotator section would just fall down the center of this because there's actually no lip there to hold this. This basically, there's no lip on here for this entire, or ledge for this entire top section to kind of rest on, so I'm going to have to come in here and eventually actually edit that a little bit. As well as actually probably trim down the sides of this to make it fit better. So that's not going to be much of a problem because of the way that my rotator architecture just works with my slip rings that I use to make this kind of fit properly. Dubrox5539, I'll text you everything else I adjusted properly. Z offset, bed level, flow rate, etc. I think the next thing is retraction speed. Okay, you can try it out, see if it helps. DJ Jakey says, "Hi, DudeRock5539. It just sucks with the enders since you actually need to adjust the level of the bed, despite the model I have having auto bed leveling to help out, but it's manually adjusted correctly as well. Yeah, it's kind of annoying. Well, I mean, like the Prusa, the i3 Mark III's that I have too, or the i3 Mark II's. I forgot. That one, it has auto bed leveling, but the way it doesn't actually physically adjust the bed, it just like it will measure different points in the bed and then account for it in the code so that it will usually just it'll know that, oh, this edge of the bed is a little bit higher, and it will compensate for it by just adjusting the Z height. But yeah, I know what you mean. I know what you mean. So let's go ahead and we have to add this little lip. Also, this size is gonna be too tight because this is assuming perfect tolerance with this. So you can see there is absolutely no gap in between that top of this cabinet and the bottom. So this is gonna have to be just a little bit larger, just by a hair. And I can actually do that by coming in here, getting rid of this analysis. I don't want to see that. Coming in here, doing a sketch. We'll do another center point rectangle. Where is it? There it is. Sketch off this. Center point rectangle. We'll go here. So our perfect dimension, which is right there, is 120 by 80. So let's do just a little, like just a smidge smaller than that, and see what that is. That's probably by 0.2 or 0.5. Yeah, so this is by 0.2. So that's 0.2 might actually just be fine for what I'm doing. So I'm going to say that's probably fine. So we're going to leave it there, and then I can come in here, press pull just that lip. Oh man, oh you ass. Hold on. 2-point rectangle, capture that point, zoom all the way back out, go all the way down here. Press that. Now I can press pull this. There we go. Okay, which means I'm going to shave off like just a little bit of an edge on the top of the rotator cabinet. Boink, just like that, which will cut a little bit of a groove there, so I actually have some level of tolerance between the tops. See, so now I actually have that groove, that little bit of a gap, which will allow me plenty of space to actually fit this cabinet on the top without it just like being just an absolute pain. So from there, to make sure again that this box is actually going to seal correctly, let's go in and get rid of the bottom. Why do I have two different things? Did I split this like a moron? I think I did. I did split this. We're not trying to split this. We're gonna make this the same thing. So by doing that, let me also just adjust myself a little bit. I'm getting kind of uncomfortable with where my sitting arrangement kind of is. Okay, that's a little bit better. So one thing that sucks about overalls is that like, they just start riding up on your crotch. They just kind of grab you. So also this is annoying me. This is annoying me. I'm just gonna do this really quickly. There we go. Okay, so now I need to add those little tiny lips on the bottom of this to actually support the box. So name this rotator cabinet, or rotator cabinet. There we go. Okay. All right, make that go away, and then make this go away as well. I'm gonna bring this actually back. So how am I gonna make these little edges? I think. Okay, well, how far up does this go? Let's go ahead. You know what? This is what I'm gonna have to do. I'm gonna have to get rid of this rotator cabinet, bring the top back, do a construction plane off of that, get rid of that, so I can see exactly where that piece is. There it is. Okay, so now I can come in here, 2-point rectangle. Yeah, why not? Let's do a 2-point rectangle, so I'm do one from this edge over here. I'm not gonna make it super thick, it doesn't need to be super thick, but I'll do like 2 millimeters, which looks fine to me. So let's do 2 millimeters. and general thickness all the way to the other edge. It should be right there. Yeah, 2 millimeters by 80. Okay, we'll combine that. Do another 2-point rectangle from right there. All the way over here. Do another 2-point rectangle from that edge that we just made again. All over here. I could have just done it with this with lines in hindsight, but it's not like that's super. It's not like it's a super big deal. So, okay. So now I should be able to come in here, grab this, grab that, grab that, grab that, and grab that other edge. And now I can extrude that, and that'll give us the actual little lip that's going to hold on to this top. So I'll go down about 4 mils. It's not going to be. It doesn't need to be that beefy. We'll join that, and then what's very important because of the way this is actually going to be kind of sitting is I need to actually chamfer this edge. So let's put a construction plane right there, and then we'll just move it down a little bit so I can actually split this entire thing. So let's go here and I can do an inspection on here. Okay, so now if I do analysis, that's the wrong one. Where's the analysis I want? Oh, I made it go away, that's why. Oh, you idiot. Saved the wrong portion. Fantastic. Okay, well let's get rid of that then. That was stupid. Let's just split it. I'm just going to split the body. Go away. I don't want this section analysis anymore. Thank you. Okay, so let's split this body just really quickly. I'm going to recombine it, of course. And then the splitting tool right there. Split this. I'm just going to split the rotator cabinet into 2 sections. We're going to get rid of that. Get rid of this construction. I don't need to see that right now. And I'm going to have to chamfer one of these edges so that this print can actually print this overhang. So, because otherwise this is going to try putting this in free air, and I don't want it to do that. So we're going to come off the inner edge. I should say actually the outer edge, but basically the root of this corner. We're going to chamfer all of these at least a little bit. Oh, there we go. I couldn't see it for a sec. Alright, so we're going to... What are you doing? Thank you. So we're going to chamfer this edge out a little bit, just to add a bit more volume to this. How did that do? How did that do? Did I add that lip I wanted? Okay, that looks fine. It doesn't need to be super, super aggressive. It just needs to be... Or super steep, I should say. And when I say, like, steepness, I mean, like, if you were to adjust this whole thing, like, how angled that chamfer is, you can kind of see it there on the top. The top section. I don't need to be super, super steep. Pretty much just as long as it's kind of covering up this like little edge right there, so that should be pretty good. So now this rotator box is pretty much done in terms of like what I want it to do functionally. Of course now I actually got to recombine these. So let's go in here, go back to combine these 2 sections again, add them back, rotator cabinet. So there we go. So now we have a box. Wow, fantastic. So now our box is going to be able to house, basically essentially able to house all of our rotating components that are going to be sitting in here. So let's go, and now we will make the bottom bearing that's actually going to hold the entire thing kind of upright. So we'll go to quick offset plane, and let's just, I want to probably actually, do I want to split this? I don't think I want to split this. I'm going to put an offset plane right there, and then we're going to go here and just do section analysis and see if I can split it from right there. Oh, that works. That works fine. So I'm going to split it from right there just so I can see kind of where I'm working without having all the stuff above it kind of just like in my way. So now I'm going to I'm going to do a brief little interlude just for a quick second as I go ahead and kind of I gotta go to the bathroom really quick, and then I'll be right back. So I will see you guys in just a second. We can continue on going on with the rotator section and eventually moving on from that. Of course, it's going to be a gutted rotator. There's not going to be anything actually in there to make the thing spin around, but we're going to go on and from there start designing the actual blower that's going to be there to force air into the siren itself. So I will see you guys in just a second. I just realized I had left the microphone off. I was gonna no. Well, I said I realized I left the microphone off. When I was like started talking, I was like, oh, that's right, mic's off. Stupid. So now I guess we're gonna kind of work on more like the actually putting this bearing on this bottom section. So this air tube that we've had here, and also I do again apologize for having to kind of just take off for just a quick second. But this air tube right here, we want to put a bearing at the bottom of this to be able to support this. We also do want to make sure we have enough space to put our slip rings. So I'm going to be, this is kind of one of the things that I've not actually really kind of experimented before because my slip rings that um, I use capsule slip rings, which basically they're their own little self-contained unit, which makes it really, really convenient for making these models. Because there's like, let's be honest, there's realistically like no way you're gonna fit actual functional slip rings of like the real size of like of the Thunderbolt in this thing. It's just it's too finicky. They're way too tiny to try to sit there and try to make. On my original Thunderbolt design, I did try to make them, and it I didn't get any reward for the amount of work I put into it. So I don't intend on doing that over again. So like everyone has seen, I can quickly open it back up. Whereas all of the slip rings on this model we're kind of pretty much right there out in the open in terms of what was going on. So like the slip rings were mounted right here. So there were actual slip rings that were in this thing. I mean, there's no such thing as fake slip rings, but like they were all there, but they just weren't in a good spot where I could really make it work well. So I don't intend on doing this design over again. So I've simplified this. I've got, after all the experience I've gained with both the miniature 500 and also as well as the alerter, I kind of think I have it down pat now with how I'm going to actually be doing this. So actually, speaking of alerter, I actually need to bring up the alerter because it's got a model of the slip rings in it, so I actually can use it. So it's probably way at the top. It starts with A. There we go. So I can bring the alerter back up in here, so I can actually show you. Actually, I can use for my own reference the slip ring size that I used. So the slip ring, the slip rings that I use typically fit in this little capsule. So this little capsule houses all of the slip rings. This is why that base was so big. It's because I basically had to use this base to act as like a wiring box to solder everything. And my slip rings aren't they don't have just two wires. They don't have just two slip rings. There's typically about six individual slip rings in my little slip ring capsules. So I can actually have, let me turn this notification off. So I can actually have up to 6 circuits going up the tube. Yeah, six circuits going up if you're using really 5 circuits if you're using one of the wires as a common. So what I've typically been doing is I actually have when the wires come up, I actually don't have just 2 wires going to the motor, your positive and your negative. I actually have 3 positives going up and 3 negative going up, so that if any one of those 3 slip rings or any one of those slip rings for some reason is losing contact or is a little dirty, the other slip rings that are still wired in parallel with it will actually take the load off of that one and will continue to power the motor. So it's basically so that there's no like dirty slip ring noise you normally get where it's like it makes like that kind of like just not making good contact. So I've got that all kind of refined, and it's just kind of seeing how it's going to come ahead into this thing, because I know this is going to be drawing quite a bit of current. I mean, not necessarily all for the rotor motor, but I think it should be fine. It should be fine. So I'm pretty much going to be going from there now. So let's go ahead and do another section analysis so we can kind of see where I'm at, and we'll start getting to work on actually designing the stuff for the slip rings here. So we're going to go ahead and here cut another circle. I forgot already what this diameter is of this tube. I keep forgetting stuff. I'm horrible with remembering. So let's go and actually split this again. I'm going to do a construction plane right there so I can move it down and actually split this a little bit lower. Where did you go? Where did my construction plane go? Oh, I have construction turned off. No wonder I couldn't see it. Okay, so let's split this. Split this body. And we'll use this as a splitting tool. And we're also going to get rid of the rotator cabinet so it doesn't split the rotator cabinet. Okay, split that so I can get rid of this. Actually, you know what? I'm doing it the bonehead way of doing this. Like, I don't have to do any of that. I can just do a section analysis. I'm going to measure the diameter of this pipe. The air pipe. There we go. So it's about 25 millimeters in diameter. Okay. Go down here. Get rid of the air tube now. So 25 millimeters. So 25, that would be the perfect size of the pipe. We're not going to do that. We want to make sure we have enough space. So I'm going to go a little bit oversized of that. Let's do about 28 maybe. So we do about 20. Let's do actually 29. Why not? We've got all the space in this rotator, so we might as well use it. Let's go about 29 millimeters. And we'll start bringing up this tube, which is going to act as our bottom bearing, as well as the part that's actually going to hold the slip rings there. So let's bring it up about 9 millimeters. I forgot how deep the slip rings usually fit in this. Let's see again, inspect really quick. From there to there, it's about 18 millimeters. That's kind of big. That's kind of big. It's a bit bigger than I thought it was going to be. It's pretty big. Okay, so this is about 9 mils right now. 18 millimeters brings us up to right there, which is kind of big. Like, I'm not gonna lie. That's pretty big. I think we can hide a lot of that in here, though. So I don't think it needs to be as excessive as we've kind of gone. But again, we've got all of this empty space to kind of play with in here, so I'm not super concerned about it. I'm going to go ahead and say that 15 is probably going to be more than enough to actually fit this all in here. So we're just going to go with that. We're going to say 15. So now let's remember that the diameter of this air tube is 25 millimeters. So 25 puts us right. So 25 puts us right there. So we'll go ahead and go a little bit oversized of that and make sure we have enough tolerance. Let's do 25.5 again, so about half a mil, so we have enough space for the bottom of the air tube to actually slip around and everything like that. Press pull this inner tube to get rid of it. We'll press pull it at least just a little bit, so we have just like some kind of lip there to actually hold this this rotator tube, or the whole air tube itself. Because I want to make sure we have enough space here to actually act as the bearing. We're going to cut that. Again, we're going to maintain the thickness of this air tube. So this actual inner diameter of this air tube, again, let's check the inner diameter now. I forgot what it was. It was 22. So 22 millimeters. It's all right, honey. So 22 millimeters is our inner measurement. So we're going to come in here, hollow this out to 22 millimeters. The same way. So 22 right there. We should be able to press pull this, no problem. Not the outer ring, inner ring, the inner circle. And that will come in and cut that out. Now, that's if I didn't want to hide any of the slip rings in here. So it's one thing I have to keep in mind. So I'm trying to put slip rings in this as well. So I have pretty much two options. Is that I can either bring up a little lip that's going to sit actually in the center of that air tube, which will add to acting as like some kind of type of staying or some kind of bearing, but it would also act as a seal, because that means that if this air tube comes all the way down and air is coming up through the center of this tube, obviously from the blower, you don't want it to be leaking out underneath the entire basically through the entire bearing and then out into the rotator case, because I don't want to try to be pressurizing the case. So I think what I'm going to end up doing is I'm actually going to cancel that. I'm going to keep this sketch there, though, because I'm going to use that pretty much as a good idea. And we're going to take this air tube again. We're actually going to extend it all the way down this time. Just a little bit further, at least. So I can just do that. It's going to freak out Fusion a little bit, but it's no big deal. So now I can kind of get more of an idea of where this tube is going to sit. So 97 millimeters is pretty deep. I mean, it's kind of far. I think. So I do need to make sure I have enough space to actually fit the slip rings in here. I think what we're going to do is actually going to do this. We're going to get rid of this. We're going to cancel that. We're going to cancel that. We're going to get rid of this air tube. We are actually going to extend this lip up a bit higher, just so I have a lot of room in there, because I'm gonna need that room. This is kind of where it gets a little inventive with what I'm going to be doing. So if things don't make sense, at least currently, it'll be all right. So our air tube is right there, so we're getting kind of close to it. This is make sure I got enough space here to actually fit the slip rings in there. What I want to do. So from there to the bottom, how far is that? 34 millimeters. Oh, that's plenty. Okay, whatever. That's plenty now. Alright, so now I can actually, that also gives me enough height to actually add gussets into this if I wanted to do that later, to kind of add some more stability to this thing, to make sure that this whole tube doesn't want to flop over, especially when it has a really heavy horn on it, or projector. So, okay, so our slip rings, I have this whole entire thing in here. Let's go ahead and get rid of some of these bodies so I actually can see what I'm doing. Boom, 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 boom. Slip ring placeholder, that's what I want. It's right there. Yeah, I just want the slip ring, basically, so I'm going to get rid of these rotator gears as well. So there is the placeholder for the slip rings, so I know what size those are. And I'm going to use measurements off of this rather than going and grabbing the other slip ring, because I know this kind of model I made actually works. So again, this whole thing is from top to bottom, 20 millimeters. 20 millimeters in height, and in diameter, 12.5. So it's actually coming here. I'm going to cut a circle 12.5. Well, a little bit bigger than 12.5. Actually, can look at how big I made that hole. Nameplate gear guard. Where's chassis? There it is. There's a chassis. Actually, no. Bull gear. Okay, so how big did I make this bull gear? What's the diameter of this? 12.75. So I didn't go up super big, so it's still pretty tight. Okay, so 12.75. We can just copy that. We can emulate that right here. So let's do 12.75. Okay. Whew. That went crazy. Okay, so 12.75. Let's go ahead and just actually go pretty much all the way to the bottom with it. $20. 15. It's a little shallow. It's a little shallow. Let's go ahead and actually bring this up just a bit more. You'll understand why I'm bringing it up so high in just a second. So I hope you guys understand why I'm bringing it up so high. Okay, that looks all right. So let's make it. It's gonna be pretty tall, which is somewhat kind of unavoidable, but it's just because of the slip rings I'm using. So 15. What is it again? It was 18. I hate that it goes away when you switch in between the two. 20 mils. 20 mils. Yeah, so let's just say I'm just going to do that. That should be more than enough. Yeah, that should be more than enough for the slip rings to kind of fit in here pretty well. So I'm just going to say that that's plenty for that. Okay, and now the problem is that there's no air holes now. So I also need to make this a little shorter now because I made it actually too big. So we'll back that up a little bit. Basically just enough for it to sit on this lip right here. Yeah, that should be plenty right there. So we're going to say that's going to be plenty for that. Okay, so now we have where the slip ring is going to be placed, but there's no way for air to get up into this thing now because of the way basically the whole thing has been set up. So what I'm going to be doing, I think what we're going to do is we're going to get rid of these, get rid of the air tube. So I have to get air into this thing somehow. Now, if I really wanted to, I could make this like overly complex, but I don't really want to do that for obvious reasons, because why would you want even more complex and annoying design? So I think I'm just going to, gosh, just like this. Not going to be a lot of air getting through that thing. It's not going to be a lot of air. It's going to need a lot of high pressure to get air through this. Especially for how big the stator is. Yeah, it's going to be hungry for air. Hmm. Because I have an idea. I don't particularly like it, but I have an idea. It's been a while since you've seen the chat. Yeah, no one's talking right now. Everyone's kind of quiet right now. I have an idea, but I don't really like it for what I would want to do to kind of solve this issue. I'm thinking, like, well, what if I instead, because I have so much space in this rotator to kind of work with, what if I came up from here instead? Get rid of this air tube. What if I came up here like this? Basically making essentially a plenum. If I just make a plenum, that's going to go all the way up to this top. No, what are you doing? No, 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 please. Thank you. If I come up here and do this, if I make a plenum to actually direct air around this entire kind of bearing area. There's the air tube, there's the air tube. If I do that, that really is starting to kind of steal, it's really starting to kind of steal space from the rotator now. It's gonna be a pretty big bulk here in order to spin this whole thing. Okay, if I did that, I like that idea. Yeah, I like that idea a lot, actually. I wonder if anyone in the chat actually kind of knows what I'm going with. Oh, my cat's sneezing now. Sent you something on Etsy. Nice work, Connor. I like how it's going. Thank you. See, and don't worry. Like I know that the chat's been kind of quiet. I think people are just kind of either there's just not a lot of people in the chat, or there's like just kind of just listening to it rather than actually kind of interacting, which is fine. You guys don't have to say anything. I'm just letting you guys know that. I'm kind of working through a bit of a solution in my head as to how I think I'm going to solve this issue with it being definitely choked for air. I think I have an idea around it. Is that 1 millimeter? That's way too thin. Two, at least two. I'm not gonna join this. Oh, there's a guy riding down with his dirt bike right now. Okay, what's this? What's this? What is this measurement? 46. What size is this air tube again? I keep forgetting. This air tube is 25 millimeters. I'm curious if anyone is able to actually figure out oh, sorry, that was probably extremely loud because of this microphone. I'm kind of curious to see if anyone actually kind of knows what my idea is here with how I'm going to make this work, because clearly this little, by the size of the air tube, like how thick this air tube is and how much space is going to be occupied by just the slip rings, there's not a lot of air that's going to be able to get through this thing. And it's really kind of concerning me as to how it's going to work. But I've worked out my solution for it. I'm really curious if anyone kind of knows what I'm doing here. I'm just really concerned. I'm really concerned about this thing just being like starved for air and not being able to like generate nearly as much noise. I think we pretty much got it now, actually. Let me get rid of this. I need to generate a tangent plane. Hold on. I need to... Yeah, tangent plane. Okay, how am I going to do this? Let me get rid of the rotator cabinet, actually. And have just this. Okay. Pull this drop down menu real quick. Okay, so got that there. Sketch something really quick. All right, I think this is my idea for how to solve this issue of this kind of capsule being way too big to actually let any like sizable amount of air through this. Is that instead of having, let me do this really quick just so I can just to better illustrate what I'm talking about here. Get rid of that too. Which wall is this? It's right there. Okay. It's not my favorite. It's not my favorite solution to this kind of air starvation issue. Which I know just would would be a problem. Just because of how much air the Thunderbolt freaking draws. It sucks in so much air. So it's like I'm just super concerned about it not having enough in order for it to actually make the proper noise. But this is kind of what my solution to that is, because clearly the slip rings are going to fit in right here, and that's nowhere near enough space to effectively let air in here. Like, say if I had like a couple holes, like if I drilled a couple holes right here, for example, I probably wouldn't even do it with holes. I probably would do something else. But like if I was to have a, I don't know, like let's just do a line. Let's just do this. Let's say, for example, I did just like 1 millimeter um, supports kind of coming off, and I did a whole bunch of those to kind of space this out. You idiot! What the hell did you select? Oh, no wonder. That's because those lines just didn't go all the way to the other end. That's why. That's my fault. Yeah, because the stupid air tube is in the way. So it tricked me into thinking it was actually longer than it really was. Like, let's say, and don't worry, a lot of this stuff doesn't make any sense, probably just to most people right now. It will probably in about a second. Just give me just a second. No, that doesn't work. God, this thing that with the rotator cabinet is so annoying because it's so big, so it's just like in my damn way every time I'm trying to cut something. I don't know. It's just like I'm trying to think of realistically like how this would be done. It'd probably be more like this because this is the edge of that, so a little bit wider. Okay, let's try that. Cut in half, please. Thank you. Yeah, so let's cut all of that. Wow, thanks. You did absolutely nothing, Fusion. I wanted to show this really quick, but it's struggling with me because it's just being stupid for no reason. I just want you to capture these faces, a couple of these faces, and that's basically about it. I don't want you to do a whole bunch of extra shit. Alright, let's see if I can get it to capture just this. It doesn't want to because it wants to capture the whole bottom of this rotator panel. That's why. Let's try that and see if it does it now. Oh, there we go. Now it did it. Okay, well here's another idea. That like if I put this stuff all back in there now. Sorry for going quiet for a while. I was just trying to be really focused. But yeah, so I basically have two ideas. Is that I can either to get air up into this actual the actual chopper section of it. So the chopper section's up here. Motor sits right here. There's the rotor. There's the stator cap and all that kind of stuff. All that jazz. Blah 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 blah. You get all that. In order to get enough air through here, because if you look at how big this actual stator port is for it, it's pretty big. It's a pretty big port. So I want to make sure that I'm actually going to be able to feed this thing. And with the design I had for a split second there, it would have been really difficult to do that because essentially this entire thing would have had to force all of that air from the blower around this basically around this entire thing down here in the bottom. It's actually sitting down here because the slip rings are going to sit in this little cutout area here, and the air would have to come up from the bottom around the slip rings with that limited kind of channel space that you see right there around here, and then actually up into the air tube to then go all the way up into the bottom of the chopper. So one of the solutions I had for that was that if I didn't want to do all that and have it kind of try to direct around the slip rings, which is a bit of a hassle, I could instead have basically a collector that's going to be on the bottom of this thing. Basically a bottom piece, a flange is going to go around here, basically to allow air to come up and go into these holes. Pretend like this section isn't there. Basically to come up through these holes instead, to then essentially completely fill this little chamber right here, this little sealed chamber right here with air, and essentially completely bypass the slip rings altogether, and then enter the air tube through the slots that are actually cut into the air tube right down here in order to actually go up and feed the Siren with air. I probably could actually go with both of these designs, to be honest, to make sure that it's getting as much air as possible to the actual head of the Siren, to basically essentially maximize its performance. But I don't know. It's just something I was just kind of thinking about. I mean, I'd be more concerned about air kind of bypassing from two directions now, basically essentially adding two different leak points for it, because air could very clearly leak out between this gap between the actual top of this little plenum and the air tube, as well as coming up from the bottom around the slip rings and leaking out on this top edge right here. It's just one of the things I was kind of concerned about. If I get rid of this air tube, does that lip still stay there? Yes, it does. Cool. Just want to make sure. Because essentially this is going to act as the bottom bearing. So a section of the air tube is actually going to be taking all of the weight of both the chopper section and the horn, and all that weight is going to be basically sitting down on top of this. With enough back pressure, the blower actually kind of helps to somewhat float the entire head off of that bearing. So it's essentially it's almost like an air bearing, especially with the old Thunderbolt. That's how that one worked. Was that basically the whole thing? The back pressure from the blower would actually lift the whole Siren head off of this bottom bearing right here, essentially floating the whole thing. So it would act like an air bearing, like I was saying. Whereas with this, I'm not sure if the blower is going to have enough back pressure to actually float the entire head of this thing, because it's just by its nature, it's probably going to be heavier than my original design. So I don't know. It's something I'm thinking about, and it's just kind of concerned if it's going to work or not. So see if we got anything else in the chat. So we got 3 viewers right now. Midwest Siren Productions says I'm still here just listening. Cool to see MSP in the chat. Siren Guy 911 says not bad. You should look in the chat and take a break for a little bit. Yeah, I guess I kind of can. So this is kind of what we got so far for the the rotator section of the Thunderbolt. There's not really that much that I've done in terms of blower design. People have seen, I talked about it a little bit with the intermediate pressure blower that I had been designing for a little bit, which is a centrifugal based blower. It's not going to be a root style, as I described earlier on the stream as to why that's not going to work, especially at this scale and this material. But I guess I can kind of go back to what this blower looks like. So this is, again, is one of the prototypes of this blower for the Thunderbolt. But I'm not going to be using, again, I'm not going to be using that RM130 motor. I'm going to be using something a little bit larger. So I was actually looking at 380 size motors, because 380 size motors are typically going to be a lot more powerful. They're going to have a lot more speed, and it'll work with the operating voltage I'm choosing to go with this Siren. So there's a Johnson, a name brand motor with a pretty long shaft, which I think would work pretty well for my uses. And that would most likely be used for the blower motor because it's just a lot stronger. It's actually got holes through it, so I actually can pull cooling air through it to keep the motor cool while the blower is running. And yeah, a whole bunch. Because I mean, people actually probably didn't know this, but the blower I had actually designed for the 120 was actually the blower actually cooled the motor. So in the pressure case that actually was being pressurized by the air coming from the impeller, some of that bleed air that's coming out of the compressor section, I actually had designed so that it could actually get to the motor. So once the Siren was actually like dead stalled, like it wasn't letting any air through the stator or the chopper section, I should say, it would actually build up enough back pressure in the blower to force air through the motor and then out the back of the blower. So some of the pressure was lost just going through the motor to keep the motor cool because it was a big like 550 motor, which has a tendency to get pretty hot. So look on Etsy what I sent you from Mom. But do that thing later. Look on Etsy. Okay, I'm looking at it right now. Let's see what it says. So this is kind of just a little bit of a departure for what we've been doing. I'm just taking a look at some chat and some stuff I've been sent. But yeah, let me, I don't know, kind of think of something about it. Think of you can consider yourself part designer with what we're kind of going with. Do you think I should kind of keep with this plenum design, or actually just scrap this, seal off those holes in the air tube, and actually just go back with trying to have it kind of force up to the center? Be kind of curious to see what you guys are thinking yourselves. 7-2. Oh, okay. Mm, okay. Yeah. So chat is kind of slowed down a little bit. Which is to be expected. It's just it's getting later on. The stream's been going for quite a while. But yeah, I might be spending some more time kind of working on this design myself. And seeing kind of what I can get from it. Because there's a lot I can't really do, and it's just been a while. So I'm going to be trying to probably work on this a bit more myself in my personal time really kind of refine this. It is getting late. Stream's been going on for about probably a couple hours now, at least. I usually do my streams for about 3 hours. But we'll probably diverge here, and I'm probably going to go on and complete some more of this stuff myself. Um, and yeah, I think that's pretty much about all I can really say. I know today was kind of a bit of a wild kind of all over the place kind of stream. I got my ADHD was coming in at full force this stream because I kind of got distracted by everything really quick. But yeah, I'm gonna go ahead and start printing some parts. I'm gonna start actually printing the rotor up here, which is gone now. I'm actually gonna try printing the rotor, and we're gonna see what this actually sounds like. Because I'd be really curious to see how it sounds. Because I have the little prototype so far, the single tone at least, the 5-port single tone. And I'm really curious to see what it would sound like with dual tone. So I might go ahead and start getting this printed, seeing what it sounds like, playing around with it for a little bit. And yeah, so I guess pretty much we'll be leaving now. I appreciate everyone for joining the stream, kind of getting a look at what's gonna be pretty much probably coming up next. It's gonna take a while to refine this, but I assure you I'm probably gonna be printing this slowly but surely. I can already tell it's gonna be a really long print to make this whole thing. But yeah. So yeah, I'd say that's probably gonna do it for today, guys. I know it's kind of been an all over stream. I hope to kind of put out some more longer format, not necessarily long format stuff, but some longer videos later on during the week. So some like my regular stuff, not necessarily my live streams, but putting out some of that stuff on the channel so you guys can have some more things to satiate yourselves with. But yeah, so I want enough. That's gonna be enough talking for me. I'm gonna go ahead and take off and kind of work on this again some more myself. But I appreciate everyone for joining the stream and getting to kind of be on here. So I guess we'll probably continue on some other day, and we'll go on with some more to talk about. This is a bit more of a slower stream, I will have to admit. It's again all over the place. But yeah, thanks for watching, guys.